Dur.
Tradoon. Tradoon.
Ontogeny.
Glue is cheap.
Tradoon. 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 Tradoon.
dirt. Location unknown.
Charter 373. This is Commander Mills. My ship was hit by an undocumented asteroid. Send help.
We've crash landed on an uncharted celestial body.
Location unknown.
The atmosphere is breathable. There's something alien out there. You need to be quiet and move.
Well, hello, everybody, and welcome back to Paleontologizing. It is so good, excuse me, to see all of you here today. Happy Wednesday to you, if you happen to be watching live, like everybody in chat is right now. Today is Wednesday, January 15th, 2025. Already halfway through the month of January, can you believe that? Shoot. Anyway, on today's stream, we're going to be talking about this brand new Carcharodontosaur dinosaur. I guess I can't say brand new. We'll be talking about why it's not brand new, which is very interesting in and of itself. Yeah, it's from Egypt. We'll be talking about Tameryraptor. Tameryraptor markgraphi, if memory serves. And hello, Sweetie Pie, how are you doing? Already, we're getting an interruption from one of our feline landlords here. Hello, Sweetie Pie.
Tradoon.
And we're also going to be assembling a 3D printed Stegosaurus skull, which I'm very excited about. It's been just kind of sitting around for about a month now, so finally got a chance to put it together. And we're going to talk about Stegosaur anatomy, we're going to talk about skulls, we're going to talk about homology. It's going to be a nice kind of teaching moment, so I've been excited about this. Anyway, if anybody's here for the very first time, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. I am being, I'm not sure if it's helped or hindered in this endeavor, by Sweetie Pie here. She's one of our feline landlords that lives in this house. Huh, Sweetie Pie? Yeah. As a paleontologist, I study fossils. I publish on fossils in the scientific literature. I dig them up during the summers. I'm going to be doing that again live this summer from the field, broadcasting paleontological fieldwork hopefully from Wyoming and Utah, possibly Montana, possibly here in California too, maybe a few other places also. So exciting stuff coming up. But yeah, here on Twitch, here on Paleontologizing, we talk about fossils. We talk about the history of life on Earth. We talk about extinction and evolution and biodiversity. We talk about species conservation. We talk about this grand pageant of life on our incredible planet Earth, with a special emphasis on dinosaurs, because dinosaurs are actually what I study, what I specialize in, what I publish on in the scientific literature, all that good stuff. But conversations, discussions take us far and wide here on Paleontologizing. So if you have questions about anything related to natural history, don't hesitate to ask those questions. Yeah. And Nathaniel sources, are there dinosaurs found in California? There are a few. I might be working on one of them this year. We'll see. There's precious few dinosaurs from California for a number of reasons. California was mostly underwater during the Mesozoic, during the age of dinosaurs, but we do have a few different dinosaurs that have been named from our state, from mostly Southern California. We've got Augustinolophus, which is our official state dinosaur. That's a hadrosaur, Saurolophine hadrosaur. And we've got Aletapelta, or Elitapelta, depending on how you want to say it. An ankylosaur, an armored dinosaur. We saw that in person down in San Diego when we streamed from the Museum of Natural History in San Diego back in September, right before TwitchCon. Really cool specimen on public display. Anyway, Sweetie Pie, how are you doing? Do you want some treats? I'm here to collect your due. All right, let's make it happen, sweetie. Let's make it happen. Ooh, yeah. There we go. There you are. Look at all those treats. May have given you too many. We'll see if you finish them. Good stuff. Here's another one for you. Yeah. Anywho, I'm so glad you're here, everybody. Welcome back to Paleontologizing. Should be a fun stream today. Actual Reverence says no such thing as too many treats. Sometimes if there's too many, the cats won't eat them all, but we'll see if that happens right now. Sweetie Pie looks pretty eager to chow down on some treats. Anywho. And Nathaniel Soares says, so is Augustinolophus related to Parasaurolophus? It's not super closely related, but they both are hadrosaurids, for sure. So Augustinolophus is closer to Saurolophus. Augustinolophus right here. There we go. It was previously described as a specimen of Saurolophus, and I think maybe Prino Marquez, maybe Bucky Gates named it. I forget, but it's got its own genus name now. Kind of like the dinosaur we're going to be discussing, our new one from Egypt today. It was Prino Marquez. Okay. So yeah, it is a duck-billed dinosaur. It's a hadrosaur from the very late Cretaceous. I want to say it's like maybe late Maastrichtian. So from the very end of the age of dinosaurs, basically. Yeah. Anyhow. And Fedora Source says, Danny, I like that you decorate your office for each stream. Yeah, I don't know. I want to keep things fresh and interesting. Not just in terms of what we're talking about each day, but in terms of the visuals. You know? I'm lucky enough to have so many cool, well, 3D prints and stuff. 3D printer. I run this as often as I can. I actually have 2 3D printers. One of them is out of commission right now. Still waiting on some parts for it. But I'm printing a juvenile Triceratops skull at the moment. Printing one of these for a friend, another one for a museum in North Dakota that I'll be visiting at the end of the month. And then I'm printing one for myself too, because I recently made a delivery to the Children's Natural History Museum of Fremont, California. Here is our baby Triceratops skull that we've had in the office for years and years. And its new home is the Children's Natural History Museum of Fremont. So I had to print a replacement, and now I'm printing some for some other folks too. One of those is done. It's right here. Yeah. This one finished yesterday, and I was able to assemble it last night. I think it looks pretty snazzy. Still needs to be painted, but I really like this filament color. The copper color is really, really nice. Yeah. So anyway, this is the youngest, the least ontogenetically mature, the smallest, youngest baby Triceratops anywhere in the world. This is UCMP 154452 is the specimen number. Goodwin et al. Published on this back in 2006. And Buff2381, thank you for the 2 months of support.
I finally got streaming. Still living in Italy until July, so there's
Nice,
a 9
okay.
hours time difference.
Oh boy, yeah.
Anyway, I was curious if you have ever excavated a giant dinosaur snake or anaconda.
I've never excavated any fossil snakes, to my knowledge, no. Snakes tend to have pretty distinctive vertebrae, so if I'd ever dug up a snake vertebra, I would think I'd be able to recognize it. I would hope so. But no. If you're, I used to hang out with Jason Head, though, who worked on Titanoboa. There's Jason right there. He was at Berkeley for a while when I was there in high school. And, yeah, I think he's got I think that's a vert from either a boa constrictor, so kind of boa, maybe an anaconda, the yellowish one, the small one, and then there's a vertebra of Titanoboa. This is a truly enormous snake that lived just after the extinction of the dinosaurs. This is from, I think, the late Paleocene epoch of the Paleogene period. Yeah, this is, as far as we know, the biggest snake that's ever lived. Although there's one from India now that kind of rivals it. Anyway, here's a model of Titanoboa swallowing a croc, which, yeah, they probably did. Anyway, I've never worked on any fossil snakes at all. Fossil snakes are really rare, it seems, until after the extinction of the dinosaurs. They only evolved. Snakes only lose their legs in what, the early Cretaceous, I think? Yeah. Prior to that, they had little legs. Snakes evolved from lizards. So snakes are a kind of lizard, strictly speaking. And some of the earliest fossil snakes that we have still have legs on them. They hadn't completely gotten rid of them yet. Anyway, it's interesting stuff. If you want to read about that, Cretaceous-legged snake fossils shed light on the evolution of modern snake body plan. There should be a nice little primer for you. I'll give you the link right there. Yeah. So yeah. Yeah. Anywho, I hope all that makes sense. Yeah. But yeah. Anyway, on today's stream, we're going to be talking about Stegosaurus. I'm going to be assembling our 3D printed Stegosaurus skull. Here's an older 3D printed model. This is from the University of Wyoming here. I don't know how much of it is sculpted and how much of it is actual real bone, but it's not got a lot of detail on it. It was a pretty low-res scan. I was really happy when another file became available online. And here's the pieces right here. We're going to be assembling this in just a little bit. And again, we'll be talking about skulls. We'll be talking about homology. We'll be talking about why those same bones in your skull are the same bones in a Stegosaurus skull. They might look different, but they're the same bones. That's homology. And then we're going to be talking about the dinosaur named after this guy, Richard Markgraf. This dinosaur was just published yesterday, I think. A new genus of Carcharodontosaur dinosaur, kind of Allosauroid. Picture like a giant Allosaurus. And then modify it a little bit. It's related to things like Carcharodontosaurus. Giganotosaurus, Mapusaurus, etc. We'll be talking about that dinosaur in a little bit. And right here on Twitch, I'm not sure if he's still in the chat, but PaleoStream, that's his handle on this platform. His name is Joshua Knupe. He's an increasingly well-known paleo artist. He did the life reconstruction of this animal that's there in the paper. So, yeah. Pretty cool stuff. I'm excited to talk about this. Oh, and I have some additional Tameryraptor graphics if required. PaleoStream, I would be all about that. If you could, if you could deign to provide us a link or two, that would be awesome. I'd be thrilled to show those off. Yeah. If anybody's not yet following PaleoStream, you're missing out. So PaleoStream works on paleo art live on Twitch here, and also encourages other people to practice their own paleo art skills. It's a neat, laid-back, like, relaxed, but, you know, let's work, let's improve kind of stream. And it's not solely focused on the art. There's a lot of scientific discussion on PaleoStream, too, because that's what paleo art is. It's... I don't know if I could say it's equal parts, because how do you quantify these things, but it's part art and part paleontology. That's what paleo art is, the reconstruction of extinct organisms. Trying to figure out what they looked like, trying to flesh out their environments, trying to provide a picture of what things were like at these various times throughout Earth history. If that sounds cool to you, go follow PaleoStream, and yeah, it's good to have you here, Joshua. Yeah. Anyway, yeah. And Nathaniel Source says Saurophaganax. You mean, Danny? That has been sunk. Saurophaganax, at least according to that paper that came out at the end of December, that name should maybe no longer be considered valid. Did you hear about that, Nathaniel Source? We talked about it here on stream. And there we go. Thank you, PaleoStream. Excellent. Oh, beautiful. And it's right there on Blue Sky. Oh, excellent. Good stuff. Good stuff. Oh, here we go. Oh, wow. Here, I posted this earlier, too, before we got started with today's stream. It's just a picture of the background. I thought it looked cool today. And, Whitmer Lab liked it. Well. I didn't know Larry Whitmer's lab followed me. That's awesome. Anyway, yeah. If you want to take a look at that post, here's a link. Anywho, we're going to get started with our Stegosaurus skull assembly. Then we'll move on to Tameryraptor. This is not Tameryraptor here, but it does have a nasal horn here. This is a Ceratosaur. It's the eponymous Ceratosaur. This is Ceratosaurus here. Tameryraptor, despite being a pteranodon, despite being an allosauroid, it seems to have a vaguely similar kind of ornamental feature on its nasal. A little horn, or crest, or whatever you'd like to call it. A lot like Ceratosaurus, so I figured we'd throw a Ceratosaurus on there. Ceratosaurus should feel right at home alongside its contemporary Stegosaurus. Stegosaurus and Ceratosaurus are, they were what we call coeval. So they lived at the same time and the same place in the Morrison biota, this kind of series of ecosystems that's preserved in the Morrison Formation. So Stegosaurus and Ceratosaurus would have encountered one another. They would have lived side by side. In fact, you could say,
And they were roommates.
Oh my god, they were roommates.
yeah, maybe not quite roommates, but they definitely lived in the same environment.
And they were roommates.
They were roommates, yeah. Sorry, I didn't mean to play that again. Anyhow, yeah. And any evidence of interspecies interaction in their fossils? I'm not sure about that, Murph. I don't know if we have any Ceratosaurus fossils that... Here's the thing, with the Morrison Formation, we've got multiple big theropod dinosaurs walking around doing their thing. You've got Allosaurus, is by far the most common big theropod in the Morrison Formation. Torvosaurus is there too, it's a big megalosaur. And then you get Ceratosaurus. Ceratosaurus is down here in the red. Right there. Ceratosaurus also gets bigger. Don't let this fool you. They're not always small animals. But the reason I bring this up is that if you find bite marks on, say, a Stegosaurus skeleton, if you find bite marks on Stegosaurus bones, it might be difficult to tell whether that's from the really common Allosaurus, or from the much rarer Torvosaurus or Ceratosaurus, or maybe even some other theropod from the Morrison. If you found shed Ceratosaurus teeth, the teeth themselves are distinctive enough that you could identify which theropod it came from by the teeth. So if you find shed teeth alongside a Stegosaurus skeleton, then you could say, yes, this Ceratosaurus was feeding on this Stegosaurus. I don't know if we have that. We do have what seem to be pathologies in Allosaurus skeletons that may be the result of getting poked by Stegosaurus tail spikes. Yeah. But I don't know if we have that in Ceratosaurus. And also, I'm not sure how much of a slam dunk this is for Allosaurus. I'm not sure if we really know beyond a shadow of a doubt that those wounds were caused by Stegosaurus tail spikes, you know? Yeah. I seem to recall that some workers who do Morrison stuff think that this might be overblown, but I'm struggling to recall any details. Anyway. And Marika says, why does Ceratosaurus have that little horn thing on their noses? We'll talk about that when we get to our new dinosaur, when we talk about Tameryraptor, so stay tuned for that. At the outset here, I want to start our Stegosaurus assembly before we get too distracted, because I want to get that done today, so we've got time to talk about our new theropod. So let's get into that. Let's start working on our Stegosaurus here. Let me get set up for this. Get our camera set up. Put this over here to protect my desk. And let me go get that glue. Be right back.
Girder.
Introduce.
There it is. Okay. There's our workspace. Let's Stuff aside. Tools already. We'll focus here. Yeah. Let's get into it. Let me grab a paper towel and then grab our Stegosaur skull bits. I figure we'll just start the assembly here. And then as we look at these different skull bones, see what questions arise and what I think is interesting enough to discuss in terms of what these different bones are and their purposes and everything. So let's do it.
Glue is cheap.
All of our pieces. Let's assemble our lower jaws first. Because why not? There we go. So I've got our dentaries. Our distal dentary and predentary here. So, first off, these files right here, the prints that I made from these files are not going to be 100% scientifically accurate in the sense that there's some artistic license in here. Stegosaurus is a complicated dinosaur. We're still kind of figuring it out in a lot of different ways, and it's the most well-known of all the Stegosaurs. So it kind of shows how mysterious this group is as a whole. There might be multiple species of Stegosaurus throughout the Morrison Formation. That's kind of argued over. There might be multiple genera. It seems like we've got Stegosaurus and we've got Hesperosaurus, and there might be other genera in there too. Who knows how many species? They might be geographically separated, or they might be stratigraphically separated. But the point is, the reason I bring this up is that when we talk about Stegosaurus, it might not be that every dinosaur that looks like this from the Morrison is actually Stegosaurus. And so different skulls that have been found, that have been referred to the name Stegosaurus, they might not actually belong to the same exact animal. You might have a bunch of members of the Stegosaur family from the same time in the same place, or from slightly different times in the same place, or whatever. The picture is complicated, that's the point. And so some of these critters we might not call Stegosaurus in 5 or 10 years' time. Yeah. When we're talking about Stegosaurus skulls, there are some kind of classic ones like this. I think this is actually a cast of the specimen at the Smithsonian. This is the one that Gilmore worked on back in the early 20th century. It's the same one that I have 3D printed right here. As you can tell, there's not a whole lot of detail. I'm trying to find the sutures between the different bones. Looking for like any fine scale anatomy here. It's really tricky. It looks very like blobby, very low res. I'm not sure how much of the original was reconstructed with plaster and other materials. I'm not sure how much of the original morphology has been obscured by this stuff. Yeah, which is why I wanted to print and assemble this one, where we've actually got different skull bones. I'll show you where I got these files. right here. Where did it go? Bolts 3D. There we go. Ugh. This is what it should look like fully assembled. It looks like the artist took a lot of the same components from the original holotype and then maybe tried to get rid of some of the plaster reconstruction and stuff like that. They've actually looked at some privately held specimens too. So, yeah, this is about as good as we can get for like an accurate Stegosaurus skull as I understand it. So that's what we're doing. I'll give you a link. And Statler and Waldorf, hello to you. Are you typing in from the balcony right now? You gonna heckle us? Welcome, welcome, Statler and Waldorf. How are things? Okay, we're gonna assemble our lower jaw right now. So let's get into it. We've got our pre-denary right there, and that's gonna fit on like this. I'm gonna do a little bit of snipping on this peg so that the thing actually fits into there properly. We might end up doing some sanding too. Yeah, that's still not quite good enough. Make sure that that aperture there is wide enough. Yeah, let's get the sandpaper out. Be right back. Waldorf has the flu. I'm alone today. I'm sorry to hear that, Stadler. Well. It's a bit better. We can improve it, though. There we go. That's a nice fit right there. I say... can make it even better. I should have those different parts occlude pretty nicely, so there's not a big gap in between. It's going to take a little bit of extra legwork sanding here. Oh. And thank you, Bumsy Bear, for the 4 months of support. I really appreciate that. Thank you for supporting Science Outreach here on Twitch, Bumsy Bear. Appreciate you. Wrong button. Here we go. And that's maybe about as good as we're going to get right there. I want to add a little bit of flexibility to this, because we're going to have the back of the jaws articulate with the rest of the skull. So what I'm going to do is put some Gorilla Glue in here first. This is a nice kind of gap-filling glue. It dries quickly, but slow enough that it's kind of a pain to try and hold it there while it sets. So I use super glue, cyanoacrylate, to speed up the process and give it kind of a tighter hold. If that makes sense. So let's assemble this right there. Hold this for just a little bit as it starts to set. Nice, I can already feel it starting to kick a little bit. Very good. Excellent. Let's put that like that. Now again, we've got the dentary right here, which is the tooth-bearing bone in the lower jaw. And then up here, you've got something that's really special to the beaky plant-eating dinosaurs, the ornithischians. This is that beaky bone that kind of differentiates the ornithischian dinosaurs from every other living thing that's ever lived. This is something that we call an apomorphy. It's a unique trait shared by a particular group of organisms. The ancestor of all those organisms had it, and all of the descendants too. It's a distinguishing characteristic called an apomorphy. There you go. An apomorphy is a novel character or character state that evolved from its ancestral form, or plesiomorphy. Here we go. An apomorphy is something that is unique to a group. It's like a new trait that's shared among them. This apomorphy is called the predentary bone. And it's a pretty special thing. All of your beaky plant-eating dinosaurs have got this. It's there in the green on our Heterodontosaurus skull. So it's the beak bone on the lower jaw of an ornithischian dinosaur. All of them have it. Heterodontosaurus, Lesotosaurus right there. Iguanodon has got it. Triceratops has got it. Edmontosaurus has got it. I think this is the same Edmontosaurus skull that I delivered to the museum the other day. Pretty sure this is the same specimen. No, there's a few differences. This is not the same one. Anywho, that lower jaw beak bone is called the predentary. Only ornithischian dinosaurs have this. So Saurischians and Ornithischians are the two major groups of dinosaurs. They're named after the differences in the hips, but there's other differences too. Ornithischian dinosaurs like Stegosaurus right there, they've got that predentary bone. This same bone right here. So there's the suture. This is the predentary right here. And then this is the front part of the dentary. That break there is artificial. It wouldn't be there in life. So the dentary goes from here all the way to the end of there. And then we've got other bones at the back of the lower jaw. We'll talk about those in a bit. But yeah. Anywho. Good stuff. Here, we'll try our right dentary, given our left one is attached to the predentary. Let's slot the right one onto there. And yeah, we've got an okay fit, but I'm going to want to sand that down a little bit more. Later on, I'll end up filling in these seams with water putty. Yeah, because I want to highlight the sutures between the different bones. Anytime there's like an artificial break in a bone itself, I want that to kind of fade into the background because it's not anatomically important. Especially since we're using these as teaching specimens. I want the real anatomy to be front and center, you know? So there we go. That'll be nice like that. Excellent. Well, let's put some Gorilla Glue in there. Inside here. We'll get this thing glued. There we go. I'll put a little bit along here too. Excellent. I'm trying to use up the last of this super glue so I don't waste any of it. Which necessitates storing it upside down over here. We can get the last dregs out. Slot this into there. Excellent. Now what I'm going to do is I'm going to go like this. I think that's about the angle that we're going to want. So just kind of hold this way. And we don't want the jaws to go inward or outward too far. I think this is about perfect right there. So we'll just wait for that glue to cure for a minute here. Damwing says this is what real paleontology looks like. This is kind of what things look like in the laboratory sometimes, if we're doing fossil prep. But this is a vastly oversimplified version of that, you know? Yeah. Does the predenary show up in sauropods? It does not, Jody Fish. No. Sauropods are Saurischian dinosaurs. So the theropods, like Allosaurus, and the sauropods form a group called Saurischia. Sauropods don't really have beaks. But the beaky plant-eating dinosaurs, the ornithischians, do have beaks. Including that predenary bone. That's the lower part of the beak. Yeah. So not all plant-eating dinosaurs have got the predenary bone. Only the beaky plant-eating dinosaurs, the ornithischians, have got the predenary bone. Does that make sense? Yeah. And the Inca rose sand, yeah. Oh boy. Yeah. Now there's a tremendous amount of work that goes into cleaning and preparing fossils. They do not come pre-cleaned and labeled with their assembly location. That's why this is like particularly easy, what we're working on right now, you know? It's so easy that it's like eminently streamable. Yeah. And how far up the Speedo line does the predenary show up? It doesn't show up that line. The Speedos have that from the beginning. Their ancestors have that predenary bone, and so they have it too. Again, this is like one of the most basic dinosaur characteristics there is. When you get the split between the Saurischians and the ornithischians, the first ornithischians, as far as we know, they've already got that predenary bone. Here. Dinosaur phylogeny. Nope, those are all ornithischians. That should do it. Okay. So here's an evolutionary family tree, what we call a phylogeny of dinosaurs. This is a pretty simplified one. But you've got two main halves of the dinosaur family tree, the Saurischians and the ornithischians. Again, Saurischians and ornithischians. So the ornithischian dinosaur that, you know, that was the ancestor to all of these guys had a predenary bone. So that means the small-bodied early diverging ornithischians, or Speedos, they had it. The Stegosaurus had it, the Ankylosaurs, the Heterodontosaurs, the ornithopods, Pachycephalosaurs, and Ceratopsians. They all had that predenary bone. That's an ancestral characteristic that they all had. Does that make sense? Yeah. Anywho. This is kind of Dinosaur Phylogeny 101, but it's nice that we get to talk about it today. And what do you know? It's holding together so far. Good stuff. I think while we're letting this cure, while we're letting that glue set, I'll put this like this over here. Let's start assembling part of the skull. Now, I already showed you the predenary bone. That's going to be the most unique, not unique, the most specialized bone we're going to see. Because we only see that in ornithischian dinosaurs. From now on, every other bone that we go over is going to be a bone that you have in your own skull. And you might be wondering, well, what do you mean, bone in my skull? Like, my skull is a bone, right? Right? The human skull seems very solid, doesn't it? Let me show you something that'll blow your mind. I think a lot of people don't realize this. Your skull is made up of many, many different bones. In each one of these, we're going to identify in our Stegosaurus, too. Because we've got the same bones. They look very different, but they are the same bones. Haunted, I love it, says Ken. How are you doing, Ken? Good to see you. The neck bone's connected to the multitude of skull bones. Yes, indeed, Casey Snowart. I'll give you a link to this so you can look at these yourself. But this is from Whitmer Lab. I showed you earlier that they had followed me on Blue Sky. So this is a kind of exploding view of a human skull. Good for looking at all those different bones. The reason I can say that we as human beings have got the same skull bones as a Stegosaurus, even though they look very different, is because of something that we call homology. This is one of the most fundamental concepts in all of biology. Here's a clip that I like to show. We've seen it before many times. I'll show it again right now. From Neil Shubin's Your Inner Fish. When we're talking about different organisms and the similarities between them, these different parts that they seem to have in common, well, that's homology.
Marvel of evolution come from? It clearly has deep roots in the past. And you can see evidence of that in the bones of modern creatures. More than 150 years ago, scientists were finding connections between the hands and limbs of four-legged animals.
Yep.
Sir Richard Owen was an anatomist in the 19th century. He was fortunate to be an anatomist in an age of discovery. And so people were coming back to London with new and oddball creatures for him to analyze.
So he was, well, he called himself a comparative anatomist. Owen also coined the word dinosaur. So the word dinosaur was an invention by Richard Owen. He published that name in 1842 for the first time. We've only had the word dinosaur since 1842, which is kind of crazy to think about. But, yeah, before that, dinosaurs weren't really scientifically studied. I'm sure people had found bones of dinosaurs throughout the ages, puzzled over them, whatever, but it was 1842 that Owen recognized that this was a distinct group of ancient animals, and he called them Dinosauria. Anyway, it's the same guy, Owen.
And in analyzing all the different creatures, he found common patterns.
Although the overall shape and structure of each limb was very different, he started to see that there was an underlying theme.
Yep.
It was as if the same set of bones was being squashed or extended to perform different functions.
Yes, indeed.
Here's a dog. Dogs, run and jump. What do you have? One bone, two bones, little bones, and then the digits, the equivalents of the fingers or toes.
Yep.
And, of course, here's a bird. Its limb has been modified into a wing, and it has one bone, two bones,
humerus, radius and ulna,
lots of bones,
carpals,
and then digits.
phalanges.
The amazing fact is, in each of these creatures, the skeletal architecture is largely the same as ours.
Yep.
Hey, a dinosaur!
Blue Flagger, thank you for the follow. Welcome to Paleontologizing. Good to have you here.
And what was utterly surprising is that the skeleton of every animal walking the earth today
Has this fundamental pattern of one bone, two bones, little bones, fingers.
Every animal with bones has got that same pattern that's walking around on Earth today. Every tetrapod. Why in the world would you have that? If you've got creatures with wildly different lifestyles, you know, here you've got a pigeon that's very, very different from a cat or a turtle, and yet you've got the same bones, just modified for different purposes. Why would you have the same bones? It's because they inherited those bones from a common ancestor. And as those lineages split, those bones evolved into different shapes, you know?
Owen didn't know why creatures had that pattern. It was a mystery to him.
Yep.
It really took a new insight, an insight from Charles Darwin,
Old
which
Chucky D.
basically said the reason why animals have this common pattern is because at some time in the distant past, they all shared a common ancestor that had a version of this pattern too.
Yep.
According to Darwin, we should be able to trace the evolution of our limbs and hands by going back in time down our family tree. Starting with our primate ancestors, we see hands and limbs that look very similar to our own.
Yep. 5 fingers, separate thumb, the poses.
Go back a bit further to the first mammals, and we find deeper similarities in the paws. And we see how paws emerged from more distant relatives. And if we go back even further, we reach our most distant 4-legged ancestors. These animals, the earliest tetrapods, were among the first to have Owen's 1 bone, 2 bones, lots of bones pattern.
Yep.
But when we enter the underwater world, around 400 million years ago, instead of animals with limbs, we find prehistoric fish with fins. And that brings us to a great mystery of biology. How did we get from fish with fins to animals with arms and legs?
Well, we had fish with legs at one
boldly
point.
predicted that there must have been ancient animals, transitional forms, that bridged this gap. But what would such an animal look like? Would it have limbs, or fins, or both? Such a creature reflects a critical step in the origin of the human hand. I set out to find one.
And so that's what this whole series is about, Your Inner Fish, especially this first episode. Here's a link right here. Excellent stuff. If you've never seen it, I highly recommend you take a look at it. It's brilliant. But this is this idea of homology. The reason why we, me and you, have got the same bones in our skull as Stegosaurus, just they look different, is that if you go back far enough, we and Stegosaurus came from the same ancestor. I'll show you. So here's a really cool interactive tree of life. Remember we saw the tree of life in that video right there? And this you can look at different organisms and figure out when they last had a common ancestor. That's what this tree is designed to show you here. So here's humans right here. And let's go to, it doesn't have stegosaurs, but it does have ceratopsians, another kind of ornithischian dinosaur, which for our purposes for this, you know, same deal. So humans and ornithischian dinosaurs, like Triceratops or Stegosaurus, we last had a common ancestor right here. Roughly, nope, 325 million years ago. Does that make sense? So, here, reset. There we go. This is always a little bit tricky to navigate. It's not the best designed website. Whereas, we as humans look much more similar to something like a chimpanzee, you know? Because we shared a common ancestor with a chimpanzee only 6.5 million years ago. Go further out to, it's not chimps and water birds, let's do humans and water birds, or humans and snakes. You gotta go back even further. Humans and coelacanths, We shared a common ancestor even further back in time. Humans and echinoderms. Oh. Humans and sea urchins. Gotta go back even further back in time, 600 million years ago. The point is, the more dissimilar we look from another organism, generally the further back in time you have to go to where we shared a common ancestor. Is this making sense? I hope it is. Anyhow. And Balint, how are you doing? Hello, Balint. Science Streams, I hope you're having a great day so far. That's why we've got the same bones in our skull as a Stegosaurus, and why they look so different, despite being the same bones. It's because we share a common ancestor with all living things. For us and Stegosaurs, again, humans and ornithischian dinosaurs like Stegosaurus or Triceratops. 325 million years ago, we had a common ancestor. So our ancestors have been evolving separately for 325 million years. But if you went back to 325 million years ago, you could find that common ancestor of humans and Stegosaurs. Or Triceratops in this case. Same deal. Are you picking up what I'm putting down? Is this making sense? And DMWing says, so we share bones with squid? Where's our cuttle bones? We don't. So squid don't actually have bones, DMWing. If you want to go to the common ancestor between humans and squid, you'd have to go to... where would that be? They are kind of deuterostome, right? The closest we're gonna get on here is octopus. But yeah. In order to get to the common ancestor of humans and octopus, you gotta go way further back, 630 million years ago. Octopus don't have bones. Cephalopods don't have bones. There's the cuttle bone of a cuttlefish, but it's not really a bone in the same way that our bones are bones. It's not a homologous structure, so it doesn't have the same developmental pathway. It's... the cuttle bone is a totally separate, independently evolved thing from our bones. That's not a part that we have in common. Does that make sense? Yeah. Anywho, and Alda King says cuttle yeah, here. Let me show you. So there we go. Inside of a cuttlefish, there's this structure. It's not made of bone, it's made of, what's it made of? It's a hard, brittle internal structure, an internal shell found in the members of all family Sepiidae, commonly known as cuttlefish.
More protection? He simply grew spears which
Mikarsa,
his body armor.
Thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Is that the thing that birds eat? Yeah, Sparky Pugwash. So they're commonly used as something for psittaciform birds to chew on. It's composed primarily of aragonite. Very cool. It's a carbonate mineral. Human uses. In the past, cuttle bones were ground up to make polishing powder, which was used by goldsmiths. Powder was also added to toothpaste and was used as an antacid for medicinal purposes or as an absorbent. Today, cuttle bones are commonly used as a calcium-rich dietary supplement for caged birds, chinchillas, hermit crabs, reptiles, shrimps, and snails. They are not intended for human consumption. Anyway, if you want to... Well, Claire already put the link in the chat. Thank you, Claire. So yeah, despite being called a bone, it's not actually a bone. It's not made of hydroxyapatite. It's made of aragonite. It's made from something completely different from what our bones are made out of. So yeah. And Lenius says, don't kill the cuttlefish. I agree. Cuttlefish are really intelligent animals. they're super cool and super cute, you know? Yeah. Anyhow. Yeah, I hope all that makes sense. The point is, those same bones in a Stegosaurus skull are the same bones that we have, with this exception. This is a special one that we don't have. This is something that this group of dinosaurs, the Ornithischians, evolved specially. Nobody else has that pre-dentary bone. You don't have a beak bone at the end of your lower jaw. These guys did. But the teeth that you have here, in the dentary bone, your teeth have got those same developmental pathways. There's some of the same genes that code for those teeth during development. It's the same structure. Homologous structure. Does that make sense? Let's continue building our lower jaw here, shall we? Find those other pieces. There we go. Our angular and syrangular and articular should fit in just like that. Excellent. Right there. Then we'll have the complete length of our lower jaw. Beautiful. So let's assemble this, and then we'll talk about where these bones went. In the human skull, or in the skull of all modern mammals. Because it's a really interesting story. We still have those bones, but they're not in our lower jaw anymore. They are elsewhere. And you're using them right now to listen to me, even if you don't realize it. It's kind of a wild story. I think you're gonna like it. Super glue. Should do it. And let's get those on there. Excellent. Very nice. So again, this is the dentary right here that has the teeth in it. But then you've got your angular, your syrangular, and your articular. Let me show you. That'll do it. Actually, no, that one doesn't show the lower jaw bones. There we go. Haha, beautiful. Again, this looks very different from our Stegosaurus skull. This might actually be the skull of Hesperosaurus, or... Anyway. Could be a different genus of Stegosaur, different species. But anyway. And this is wrong, it's not dental, it's dentary, right there. Predentary, dentary, splenial, angular, syrangular, and then there's the articular back here too that you can't see. As human beings, we don't have these anymore. Not in our lower jaw, anyway. Let's go back to our exploding human skull. Let's explode it and see how many bones we've got in the lower jaw. That's weird. We've got just one right here. What's up with that? I'll tell you in a minute, because it's really interesting and weird. We mammals are such bizarre creatures. We really are. And I think you'll hopefully have a better appreciation for that in a couple minutes. After I show this to you. But let's get this other set of lower jaw bones onto here. This is going to require some modification to get that peg to fit in there. Let's carve this down a little bit. quite good enough yet. A little bit more. So we can't say ow my dendery. You could, little pink pony, but...
Really spectacular, spared no expense.
Statler and Waldorf gifted a tier 1 sub to Terminator_pig.
Thank you, Statler and Waldorf. I really appreciate that. Thank you for the support. That's brilliant. I appreciate that very much. Believe it or not, I do this full time. This is how I make my living, is doing outreach full time on Twitch. So any financial support that I receive, like literally puts food on my table. You're helping me pay the bills. You're supporting a starving scientist. I appreciate that very much. So thank you. It's been a dream come true to be able to do science outreach on Twitch full time. It's only possible because of the generous support of this community. So, appreciate you, Statler and Waldorf. Thank you. Someone must have got hold of my PayPal account. I'm hearing this in the old man's voices. Wonder what kind of joke or pun they would have about fossil organisms or whatever. And thank you, Ms. Art Rules.
National Hat Day. Danny, what is your favorite hat you wear? Out of the many you have, Paleo Lul move good one.
Oh, Ms. Art Rules, formerly Ms. Yvette. My favorite hat would be probably the one you saw me wear in Wyoming. My Australian slouch hat is also the hat that I've had the longest, I think, out of all the hats I've had. For like 16 years at this point. I'll go get it in a minute, but first I want to make sure that I get this in a state where it'll articulate properly. Ideally, these files are supposed to be printed with a resin printer, which I don't have. I've got an FDM printer.
Try blaming the dinosaurs.
And thank you, Golganak. Appreciate those 100 bits. We got a hype train going here? We do. Excellent.
Blue is cheap.
Might be as good as we're gonna get right there. So let's glue it up. And then I'll go get my hat. Oh, wrong button. There we go. So let's glue in here. And how powerful was the Stegosaurus bite? Not very powerful. This is an animal that didn't have big jaw muscles. They wouldn't have really needed to have a very powerful bite. As an animal that probably fed primarily on pretty soft plants, having a strong bite is not something that there was evolutionary pressure for them to evolve. Does that make sense? No reason for them to really have a strong bite. But it's funny that you asked that, because I was just looking at a paper earlier about like calculating the bite force and jaw mechanics of Stegosaurus. So it's a question that's been asked before, certainly. And okay, what just changed? What's preventing this from? All right, I'm just gonna hold it here like this. But yeah. Let me see if I can find that paper for you. Stegosaurus. There we go. There we are. A model for the bite mechanics in the herbivorous dinosaur Stegosaurus. By Miriam Rachel. This is in 2010. It was published. Yeah, little is known about the feeding habits and biomechanics of its homodont dentition for Stegosaurus. Homodont means that all of their teeth are basically the same. Homodonty. Homo is from the Latin or Greek word for same. And so these animals have got the same shaped teeth pretty much the whole line down. The presence of a Rhamphotheca has been suggested. A Rhamphotheca is a keratinous beak made of keratin. But it's still unknown how much such structure would have participated in the foraging behavior of Stegosaurus. To better understand this feeding mechanism of this taxon, three-dimensional models of Stegosaurus teeth were created using the software ZBrush. Suggests this animal was capable of biting through smaller branches. Computer modeling analyses provide additional information about feeding habits and plant preferences for Stegosaurus. Can be adapted for studying other comparable herbivorous taxa. So yeah, wouldn't have had the strongest bite in the world, but could have bit through smaller branches. Researcher was saying there, which sounds good to me. Makes sense. Oh boy. Anyhow, it's okay that this is kind of flexing back and forth like this a little bit, because it's gonna need to do that in order for these pegs to be able to fit into the skull as we put that together. But there's our lower jaw of Stegosaurus right there. Excellent. Yeah, good stuff. I'm gonna gently set this down over here. Okay, and let's talk about where those other lower jaw bones went. Because we as humans, we've got a dentary, like you saw right here. We've got this bone. In humans, we've got a special name for it, because a lot of human anatomy, you've got, you know, kind of cutesy special names. So rather than calling this a dentary, we call it the mandible right here. I think that's actually true for most mammals. You call it a mandible, or you can call it dentary, whatever you want, I guess. But these other bones at the back of the skull, the splenial, the articular, or the angular, the cerangular, and the articular, why don't we have those in our lower jaw? And the reason is, they're in our ear now. They are inside of our inner ear. So in the second part of Neil Shubin's Your Inner Fish, entitled Your Inner Reptile, we talk about this.
The transition to mammals, and it enriches our lives today. A new kind of ear.
Yep.
The hearing anatomy of mammals is unique. You won't find ear flaps on any reptile.
True.
Our ears are extremely sensitive, allowing us to pick up a wide range of sounds. From high-pitched squeaks to low-distance calls.
Okay.
And the secret of their incredible sensitivity lies in the tiniest bones in our body.
Yep. There's them.
These are the three bones of our middle ear. All mammals, including people, have these three bones that sit inside the skull. And what they do is they form a little lever system that turns the vibration of air into sound that our nervous system can perceive. We, like all mammals, have 3 of these bones in our middle ear, but reptiles only have 1.
These 2 extra bones, the malleus and incus, enable us to amplify sounds that reach our eardrum.
Yep.
Which is one reason why our hearing is so much better than reptiles. This presents us with a simple yet extraordinary puzzle. How did our acute sense of hearing using 3 bones emerge from our reptilian ancestors who used only 1?
And that's frustrating because mammals did not evolve from reptiles, and I'm a little bit frustrated that Neil Shubin put that in there because he knows that that's not correct. He's like trying to simplify things for ease of understanding, and I think just making things more confusing. Anyway, mammals did not evolve from reptiles. Mammals and reptiles both evolved from the same ancestor, but they've always been separate since that split occurred. Mammals did not evolve from a reptile. Reptiles and mammals have been separate since that split. And that's when they became mammals and reptiles. But the ancestors of mammals did look vaguely reptilian, I guess you could say. And, yeah, they used to only have 1 bone in their inner ear, and the other bones were in their jaw. That's what's important to know for this, okay?
For nearly 2 centuries, scientists have been fascinated by this mystery. And one of them is my former student, Karen Sears.
So these are the gray short-tailed opossum, and they have been used in labs for a few decades and are now becoming a much more popular lab organism. They're very cute. So the opossums, like other marsupial mammals, the mother gives birth very early compared to what we would call placental mammals, things like us, like mice, like dogs.
And there you go, Ken, yes.
These guys, you know, they're a month and a half.
Oh, there were no diapsids back then. You mean sauropsid, Ken, but yeah. Yeah. Anyway.
They're pretty big. When they're born, they crawl up here and attach to these nipples.
Yeah.
And
those are the babies right there. They're just tiny little flesh beans. It's like smaller than a jelly bean. Those are the newborn babies. Marsupial babies are born extremely small and underdeveloped. They are like Tic Tacs. I think they're even a little bit smaller than Tic Tacs. Tiny, 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 tiny. So like a newborn kangaroo, for instance, shoot, this isn't even, I guess this is about newborn here? Yeah. It's basically an embryo. A super tiny, underdeveloped embryo that crawls out of the mother's birth canal and then goes up into the pouch. That's a newborn kangaroo right there. All marsupials are born super underdeveloped like this, and they have to make that journey from the mother's birth canal into the pouch. That's what baby possums look like. They're just tiny little flesh Tic Tacs, you know? And Alexander Morrison says they're already mobile at such a developmental stage. Yeah. They've got the tiniest little, like, grabby arms, but they don't have legs yet. They don't have a tail. They're just like a little Tic Tac with arms and legs. Here. It's tough to find images of this. Because it's kind of rarely been photographed, surprisingly enough. But... oh, there's another one right there. There we go. Yeah. And you see, it's translucent. So you can see just the beginnings of the rib cage in there. But it doesn't have legs yet. It barely has these tiny little grubby arms. It doesn't even have a jaw or anything. It's just like a hole in the front of its head. And it latches onto the nipple right there and starts to feed. That's what these guys are doing. Wild, right? Yeah.
Only a few millimeters in length at that stage.
Yep.
They are almost at an embryonic stage of development. About the equivalent of a human embryo at about 40 days of development. So they don't really have hind limbs, they have no hair.
So there we go, that's it. it's just a little flesh bean, a little flesh tic-tac. It's got these tiny little arms, but no legs, no tail. It's just round on that end. How wild is that? It doesn't even have eyes yet. Like, it's completely blind. And when they get into the pouch, they continue developing. Yeah.
They can't hear at all at that point.
And see, there's just the hole at the front of the head. You could barely even call it a head, you know? Yeah. Yeah. Geek Tour says, amazing thing. It really is. Like, this will crawl out of the mother's birth canal and go up and go into the pouch and, yeah, and start feeding on milk.
These opossums are born just 2 weeks after mating. And Karen can see how their ear bones form at each stage of development from early embryo to adult.
Yep.
In order to find the bones, she euthanizes the opossums and uses flesh-eating beetle larvae to strip away the tissue and leave bare bones.
Yep. This is a pretty common practice.
These
using
dermestid
like
beetles are used by labs and museums the world over. It takes about 24 hours for them to complete their work. Karen is then left with a series of skulls through which she can trace the development of the middle ear bones from embryo to adult.
Yep.
And what the skulls reveal is astonishing.
So what's really surprising is if you look at these early opossum embryos, what you see is essentially a reptilian-style ear with one ear bone.
The state piece.
2 extra middle ear bones. They're going to be in the ear in the adult.
They're attached to the jaw right here. Just like in our Stegosaurus or in like all non-mammal tetrapods. There's multiple bones that make up the lower jaw. And again, this is like a newborn right here. It's still in its like embryonic stage, basically. But as it grows, it's almost a repeat of mammalian evolution that happens during development. So as this newborn is growing, and Chatter, thank you for the follow. Welcome to Paleontologizing. Good to have you here. As it's developing, it's almost like you're watching evolution take place. This happened in the evolution of mammals. But now that tape is replayed every time you get a baby possum that's growing up into something closer to an adult, you know?
They are part of the jaw. And so the jaw joint between the skull and the jaw really looks like that of a reptile.
Yep.
Then after they're born and while they're growing up, those little bones that are going to be the mammalian middle ear disconnect from the jaw. They get relatively smaller and move up to their final position to become a mammal-like ear.
There you go.
So if you have modern reptiles with 1 ear bone, you have modern mammals with 3 ear bones. I think what the embryos do is they almost provide a link between those 2.
Yep. So it's like we can almost kind of see how that evolved by looking at the embryonic development of possums like this. Super, super cool stuff. Really neat, right? And Plane Shifter says, lol, rewind that? Sure. Go back just a little bit.
To be in the ear in the adult, they are part of the jaw. And so the jaw joint between the skull and the jaw really looks like that of a reptile. Then after they're born and while they're growing up, those little bones that are going to be the mammalian middle ear disconnect from the jaw. They get relatively smaller and move up to their final position to become a mammal-like ear. So if you have...
Again, this is just to emphasize and try and clarify. This is something that we can watch in the development of baby possums. And it kind of echoes the evolution of the mammal ear over millions of years. It's like that same process is being repeated every time there's a baby possum.
Jump! Jump! It's Marvin!
Pretty neat, right?
Marvin Berry! You know that new sound you're looking for?
Raptor bones.
Listen to this!
Well, well, well. Welcome to Paleontologizing. It is good to have you here. Raptor bones and raiders, welcome, welcome to the channel. we're going to be talking about a brand new raptor in just a little bit. Tameryraptor, Mark Graffi, is a new big theropod dinosaur from the Cretaceous of Egypt. We'll be talking about in a little bit. It was just described yesterday, just published. So we'll be talking about that. But right now we're talking about stegosaurs. We're talking about stegosaur skulls. We're talking about homology. I'm 3D printing, assembling a 3D print of a stegosaurus skull. We've got this much of it done so far. Our lower jaws now assembled right here. And we're getting ready to work on the skull part of it. We've got our dentaries, our predenary, our angulars and serangulars, articulars and splenials. All these bones in the lower jaw here. We're gonna move on to the skull next. So anywho, what were you doing in your stream, Raptor Bones? Good to have you here. I'm not sure if we've ever crossed paths before, so let me introduce myself. My name is Danny Anduza. I'm a dinosaur paleontologist. So I work on dinosaurs. I publish papers on dinosaurs in the scientific literature. I present research at scientific conferences. I dig up dinosaurs during the summer, and I stream it. I'm looking forward to doing that again this year. And we talk about dinosaurs and about all of natural history. 4 days a week here when it's not the field season, when I'm not out in the field. When I am out in the field, in Wyoming and Utah, maybe Montana this year, maybe some other states as well, I typically stream 7 days a week. Because I want to show you what it's like to be digging up fossils in the field. I want to give you an inside peek into how this science works. But back here in civilization, in the off-season, I stream 4 days a week. So here we are.
A real mean kid. With 6-inch daggers for teeth.
Adelaide Ashford.
The terror of his neighborhood.
Thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Playing Jurassic World Evolution 2. Messing around with genetics. Oh, nice. Cool. Well, it's good to have you here. I love your channel. I appreciate that, Raptor Bones. It's great to have you here. Thank you for the raid. Welcome. So yeah, we were talking about where those other inner ear, the other jawbones went in us mammals. And Dave Crazy, thank you for the follow. Welcome. It's good to have you here. The bones that most tetrapods have in the back of their lower jaw, in mammals, those got shunted into the inner ear. Right here.
For growing up, those little bones that are going to be the mammalian middle ear disconnect from the jaw. They get relatively smaller and move up to their final position to become a mammal-like ear.
Yep.
So if you have modern reptiles with 1 ear bone, you have modern mammals with 3 ear bones. I think what the embryos do is they almost provide a link between those two. So what we see in the opossums is from that time they're born through their adult, they almost go through 300 million years of evolution in terms of their ears.
It reflects that long time evolutionary change. Mark Melbourne, thank you.
One sub to Adelaide Ashford. They have given 182 gift subs in the channel.
That's a lot of gift subs. Mark Melbourne, we've got some Australian solidarity there. Mark Melbourne and Adelaide Ashford. That makes me smile. Good stuff.
How do we know that the bones we used to hear with came from the bones reptiles used to eat with?
Well, not reptiles, but mammal ancestors.
This amazing transition we see in development from jaw bones to ear bones, we also see in the fossil record. And we see it fossils from here in South Africa. And if we look at some of these primitive mammal-like reptiles, we see something in the lower jaw that's very different from us. Because what it has is one bone here which carries the teeth, and then there's a bunch of other bones that are sort of moderately sized that sit at the back of the jaw. They form the jaw joint itself.
So
As you go forward in time,
That'll be the splenial, the articular, the angular, and syringular bones, like we see again in our Stegosaurus there. Splenial, angular, syringular, and the articular should be back here, if memory serves.
What you start to see are creatures like this, which have a larger bone that holds all the teeth, and ever smaller bones at the back of the jaw that form the jaw joint. Then we hit a point.
When you get to animals that lived around 200
Thank you,
million years
Stadler
ago,
and Waldorf. I'll see you
more
next
recent
time.
in the fossil record, you find that they have formed a
Hope to see you too.
completely
Thanks for
new
being
jaw
here.
joint.
Yeah.
That's because the bone that holds the teeth had grown so large, it made contact with the skull.
Yep.
So over millions of years, bones that formed the old jaw joint began to shrink. And eventually became redundant. But instead of being lost altogether, these old jaw bones were repurposed to take up a new role.
The inner
in the
ear. Yeah. Pretty neat. Pretty neat.
Finding out when that transition took place is difficult because the tiny ear bones sit loose in the skull and they are rarely found with the rest of the body. But recently, a fascinating discovery was made in another part of the world.
Yeah.
China. One of the leading scientists involved in the study is my colleague, Zeshi Lo, who works in a lab next door to mine.
So Lo is a fabulous anatomist. Here's a guy who knows the anatomy of the teeth, the anatomy of the jaws, the anatomy of the ears, of reptiles and mammals as well as anybody on the planet. Furthermore, he's able to work with really tiny specimens.
When the fossil was first spotted in the field, my friend thought it's just a pebble.
Look at that.
He picked it up and he realized there were bones in that pebble.
It's a skull. It's a whole skull. And this is a really neat application for 3D printing.
We know that it's actually a mammal skull, and it's related to the origin of all mammals.
They named it Hadrocodium.
Yeah.
Using a 3D printer, Lo built an enlarged replica of its tiny skull.
So there we go. That's one of the really cool things that you can do with 3D printers is you can scan a super small fossil, make a digital file, and then 3D print it so that you've got something you can hold in your hands and you can like look at from every angle, and you're not looking at a tiny little thing the size of a bean. You're looking at something that your brain can actually make sense of properly. Really neat application for 3D printers like this.
The teeth had cusps like other mammals. But it's the lower jaw that really stood out. The jaw joint looked remarkably like that of modern mammals, which suggests that the old reptilian jawbones were no longer being used to eat with. They had become part of the ear.
Nice.
On the inside of the jaw, there are structures to hold the ear bone. This shows us Hadrocodium's ear bones are still attached to the jaw.
But the attachment was minimal. Hadrocodium's ear bones were on their way to being completely separate.
Very cool stuff. Such a small critter, too.
So this 195 million year old creature, no bigger than a paperclip, had taken a big step towards the kind of hearing we have today.
This is what our mammals looked, what our ancestors looked like during the Mesozoic, during the
Along
age of
with its
dinosaurs.
specialized teeth and fur coat, Hadrocodium is regarded as one of the earliest mammals. And there was a final surprise. Another important mammalian feature inside its skull.
We originally thought the early mammals' brain were a lot smaller, but Hadrocodium really surprised us. Has a huge brain. In
Compared to
fact,
its skull size.
its brain is
It is ridiculously
50% bigger relative to its body mass than anything before it. That's why we call the fossil hydrocodium. It means it got a great big brain.
Yeah, that's what the name hydrocodium means. I was really lucky to be able to meet Jeshi Luo at SVP this year at the Society of Vertebrate Paleontology meeting. It was actually that first evening. I got to the host hotel. I met some friends for dinner. Then we went back to the hotel bar, and there he was right there. So here's me and Ken and Fisher out at dinner. There was a sushi place right next to the hotel. And then we went back, and who sits down next to me but Zeishi Luo? So I couldn't remember his name off the top of my head, but I said, "Excuse me, I recognize you, and I'm an admirer of your work. You worked on hydrocodium." And he said, "Yes." And we got to talking for a while. It was pretty awesome. Yeah. So that's one of the cool things about going to scientific conferences. Yeah, I don't know. Get to rub elbows with the giants in the field. So yeah. Yeah. And Dyson Dinosaur, yeah, we're going to get to that in a little bit. I got to finish putting together our Stegosaurus skull first, but we're going to talk about Tameryraptor. Very excited about that. Yeah, really interesting in that you can... I didn't realize that was permitted by the ICZN, the naming of a new taxon based on photographs of a specimen, rather than an actual physical specimen itself.
Wow, it's not the dinosaur we knew. Just look at that.
We'll get into that.
It's not going to be friendly to us.
Stevie Reeds, thank you for the prime there. Oh,
let's protect our fossils.
Limited Swang, thank you for the prime.
America loses them forever.
5 months from Limited Swang there. And Stevie Reeds, thank you for the prime at the same time. Thank you very, very much. Both of you. Thanks for supporting Science Outreach here on Twitch. I really appreciate it. Yeah. I went to check the ICZN rule that they use. That surprised me too. Yeah. I'll have to look into that. Yeah. And Deathsaurus, yeah, we'll get into it soon. First we gotta finish our Stegosaurus though.
Isn't he? 70 feet long. Tips the scales at a substantial 35 tons.
Shanai Led, thank you, Shanai Led, for the follow. Welcome to Paleontologizing. Alright, let's look at our lower jaws of our Stegosaurus. We've got those more or less cured now. It'll be easier to get everything properly glued once we get this attached to the rest of the skull. But there we go. Let's start working on that skull, shall we? All right. We'll start at the front. This right here is the beak. That toothless beak at the front of Stegosaurus's skull. These are the premaxillary bones. There's two of them paired like that. You see that symphysis between them right there? So this is right here at the front of the snout. Stegosaurus snout right there. So there's this. Let's get our maxillae right here, which in this file they are printed together, which is actually really nice, just to make it more structurally sound. That is going to fit in just like this. Beautiful fit. Does that make more sense now? At the front of the snout, this is the nares, nasal opening. So, shoot, let's glue it. I think we could just use cyanoacrylate too. We don't really need the Gorilla Glue for this part. Here we go. And there we are. Really nice occlusion there. Love it when they just fit together. Nice and snug. Beautiful. So there we go. There's our Stegosaur snout. Lovely. Yeah. And you can see the juncture between the premax and the max. The premaxilla and the maxilla right there. Of course, we as humans have got the same bones. Right here. There's our Explodo human skull. Let's bring everything back together there. There we go. So, our maxillae are right here. So our... Dude, the premax, it might be like up inside the skull nowadays. So this front part, the top part of the Stegosaurus beak right here, is, I don't know if you could really call it a beak. We're not sure if they had a Keratinus rhamphithecus. But, anyway, the premaxillae right here. We still have those as humans, but I'm not totally sure where they went. This is the maxilla right here, which is the tooth-bearing bone. There. So, you see the tooth sockets right here? Yeah. That is the maxilla. Now, a human premaxilla, it might even have a different name. Let's look it up. Yeah, premax. Here it is in a dinosaur. This is Spinosaurus right there. The premax is there in orange at the end of the snout. The premaxilla of Therian mammals, that's us, has usually been termed as the incisive bone. Human premaxilla and its sutures. Oh, okay, yeah, so it's right there. We do still have it. The incisive bone. Oh boy. Anyway, it's right here. So it bears the first few teeth. I guess your incisors, and then the ones lateral to the incisors too. I forget what they're called. Cool stuff. So we've got those same bones. They just look very, very different. Never realized how conservative the tri-radiate shape of the jugal is. Yeah, Dyson Dinosaur. It's pretty interesting, right? If it ain't broke, don't fix it, you know? Let's continue. Let's add some more parts on here now. What do we want to do next? Do this. On there. No, that'll be later. What we want next is our stuff near the front of the orbit. Excuse me. God bless me. Sorry. Yeah. There we are. So we're gonna try and find our lacrimal right there. And then our palebrals, prefrontals, frontals, postorbitals, all that stuff. Parts of this don't quite look right to me, but that's okay. Here we go. Here's our actual model with the assembly instructions right here. These are just numbered. I think it would have been a really cool opportunity for Outreach to actually put the names of the bones on here. But, oh well. So yeah, we've already attached the premaxilla to the maxillae right there. And then steps number 3 and 4, I guess we'll be connecting the nasal bone like that. Yeah, okay. Let's go ahead and do it. So these, 2 more paired bones.
It's a paleontologist version of heaven.
Carl Landia, thank you for the follow. Welcome to Paleontologizing. This might look like it's 2 bones or 4 bones. It's 2 bones. 1 bone here and 1 bone here. This break in between them is artificial. Just so that you can break it up so it'll fit on the print bed for 3D printing. Oh, speaking of 3D printing, our baby baby Triceratops is done. Let me go put this other file going. Hang on just a second. Excellent. Beautiful. Really happy about that. Printing another copy of this, our life-size baby Triceratops skull. This is modeled after Berkeley specimen UCMP 154452. This is Harley's baby Triceratops, found by Harley Garbani back in the 80s, I think? It was described in 2006 by Mark Goodwin et al. And, yeah. I'm making a few copies of that for me and then for some other museums. So, yeah. Yeah. Good stuff. But, yeah. Anywho, let's, assemble these parts. Again, our nasal bones here. They're gonna form the top of the snout of our Stegosaurus. So, I don't know if we actually need Gorilla Glue for this either. Let's just do super glue. Keep things a little bit tidier and quicker. There we go. Nice. Got some beautiful occlusion there. And look, our 3D printer is humming to life. We'll start the back half of our Triceratops skull, including that beautiful, super cute baby frill. Just gonna hold this like this for a minute as we watch that start. So right now it's just laying down the perimeter around the base layer. It'll be printing from the middle of the skull up toward the distal end of the frill. So we can kind of monitor that progress throughout the rest of today's stream. Should be about 9 hours of printing, I think. So it'll go into the evening. But we're good. It's good that we're getting that started now. I really want to let this set before we put it on there. Before we assemble the rest of the skull. Do you leave them like that, or do you work more to close the suture lines between them? I do, Dyson Dinosaur, yeah. So I use the same compound that we used at Museum of the Rockies to fill in gaps in fossils. Let me go get it. It's called Durham's Water Putty. I'll show you. There we go. This stuff right here. It's very inexpensive, very affordable. It dries rock hard. It's sandable. It's pretty sure it's non-toxic. And it's reversible to a certain extent. It's really good stuff. But when you look at figures of Museum of the Rockies specimens, MOR Hypacrosaurus, maybe? Yeah. So some people think that this looks really ugly, but see all the cracks that have been filled in that Hypacrosaurus skull? That's water putty on the inside there. This was like standard procedure at Museum of the Rockies. That's where I learned that technique. But yeah, I use the same thing on my 3D prints. Yeah. And I know that's called, yeah, Dyson Dinosaur, yeah. Yeah. Beautiful skull. Really nice. So I use this stuff all the time. You can get it at your local hardware store. I get it at Home Depot or Ace Hardware or whatever. I don't get it on Amazon because it's way too expensive on Amazon. But it's really cheap at the corner hardware store. So yeah, with these nasal bones here, this big crack in between, I will fill that up with water putty. But this one here in the middle, that's actually part of the animal's anatomy. These are those two paired bones right there. And so, yeah, I'll leave this, because that's actually part of the animal. This is not. So we'll fill that in, so that we're only highlighting the actual critter's anatomy. That makes sense. Anywho, according to our instructions here, steps 3 and 4. Well, this next step, okay, is to take this, or step 2, and stick it onto there. So we're going to stick it onto our maxilla and premaxilla, so let's do it. It's going to go on just like this. There we go. Yeah. So, I'll put some glue in here. And I think we are going to want some Gorilla Glue in this. Just to kind of fill up some of that volume. The super glue only goes so far. If you really want things to hold nicely, sometimes it needs a little bit of help. Some gap filler, like we get from the Gorilla Glue. Don't worry, it's not made from real gorillas. Okay. And there we are. Beautiful.
Glue is cheap.
See? In front of our Stegosaurus skull. It's really coming together. Clean up a little bit of the excess glue here before it sets. Gorgeous. Lovely. Now our next step here is in adding these. This is the superorbital and the... What What are these? Lacrimal? Really? That doesn't seem quite right. Let's cross-reference this. Lacrimal, okay. There we go. This actually looks more similar to our Stegosaurus skull right here. Maxilla, lacrimal right here, and prefrontal right there. And then we've got our jugal. Okay. So now I just got to dig through my container and find the two different lacrimals. Excuse me, and the two different prefrontals. Right there. Here, what do they look like? That is one. 1 and 2. And then that's gonna have, okay. More follow-me. Second here. Where did I put that folder? I want to make sure that I'm looking at the right file here. There we go. Okay. So it should look like this right here. Which plates yet. Take those out. There we go. Here's one of them right here. One of our prefrontal. And looks like here's the other one. Good stuff. That's that same one right there. Okay. Excellent. So that is going to fit onto here. Just like that. So that's going to form the top of the eye socket. Right there. And in turn, it'll fit onto this guy. This guy right here. Our right side. Lacrimal. Excellent. Like this. Wait a second. Seems right. Okay, cool. So let's put these pieces together. They're going to fit together just like this right here. So since we're going to want some more flexibility here, I'm going to use a bunch of Gorilla Glue. Just like that. There we go. Okay, we know we've got a good fit. We can finalize it with our cyanoacrylate, our super glue. There we go. Nice. Just like that. And then this should fit into here. Whoops. Come on, stay on, please. Oh, wow, it really didn't like that. That should fit on just like this. There we go. Beautiful fit. Just got to get everything to hold together. So I'm going to dab a little bit more super glue on there. Get some on here too. There we go. Lovely. Beautiful. So as that starts to set, I was going to say I'll clean it up with some paper towels. I'm going to want a few more dabs of glue along some of these other points where the bones meet up. Focus on doing that. And then we'll look up those bones in our own skull. And figure out where they are and what they do. The name lacrimal, does that remind anybody of a particular bit of anatomy? Any guesses what that might be? Lacrimal. Like the adjective lachrymose. Anybody have any guesses? What might that mean? Lacrimal, lachrymose. Tears, eyes? Yes, indeed. We'll get into that in a minute. Excellent. That's going to stay together once the glue dries. I'm just going to hold this here with one hand, and then with the other hand, show you our human skull here. So, with our human skull, our lacrimal bones, I think, are going to be right here. I think it's right here on us. And on the other side, right there. Let's test that hypothesis. Lacrimal bones. Bingo! There we go. Yeah. So right there, it kind of forms the inner part of our eye socket. Since our eyes are forward-facing like this, our snout has been pushed in so far that our face is pretty much flat. And those lacrimal bones, which are on the sides here, on our Stegosaurus, up here, those in us are like, you know, basically inside of our eye socket. Pretty weird, right? I see that. Very nice, Ms. Arnold. Got no snout. There you go, the Raven. Yeah. Yeah. So we've got this one on this side. Let's do our other side now. Let's see if we can get these to fit. Gonna set this down here for a second. Just gonna let it sit there as the glue sets. Let's put these bones together. So that's gonna go like this right here. Right? On our... Is it like that? Nope, it's gotta be like this. There we go. Yeah. So, let's get those assembled. Put some Gorilla Glue on here. And we'll seal the deal with our super glue. Just gonna hold that there for a minute while it sets. Put some pressure on. And clean up the glue that kind of oozes out from the sides, our excess there. Nice. It's not gross, Claire. Yeah. And Rushwing says, I bet dinosaurs never had to deal with all the issues of having all your face holes linked by sinuses. Not really. Not in the same way, at least, in dinosaurs. Most dinosaurs have got a lot of fenestrae. They've got you know, like big openings in the skull that would have hooked up to their lungs, but it's not really like, I don't know if you could call it sinuses. Here, I'll show you an example. I think at the end of one of the Saurian trailers, they show their Tyrannosaurus.
Saurian.
Yeah, here we go. So you see that right there? I wish we could get rid of these. It's a really annoying YouTube thing. In the antorbital fenestrae, on either side of the snout right there, you see this reverberating almost like a drum or something like that? So on Tyrannosaurus, there are these big openings in the skull. The biggest openings in the skull are the antorbital fenestrae. So there's a model of the Stan skull. That big opening in front of the eye socket is the antorbital fenestra right there. This and the other fenestrae, the maxillary fenestrae, the nares, these are all hooked up to the respiratory system, we think. So as these animals are walking around, doing their thing, breathing. Air is moving through all of those passages. It's, so yeah, not quite sinuses in the way that we have, but they do still have these big air passageways that are moving through the skull. I don't think you could call them sinuses in particular, but I don't actually know what constitutes a sinus versus a fenestra versus a, you know. So yeah. Anywho, it looks like these parts are just about ready to stick onto our skull. So let's do that. There we go. Put that on just like that. Nice little test fitting. Beautiful. Here, some along this surface, and a little along here too. And now our super glue. Beautiful. Nope. Upright, please. Nope. One more time. There we go. And there we go. Lovely. Superb. Excellent. Beautiful. Look at that. Very nice. It's funny, looking at it like this, it really reminds me of like a Nodosaur skull. These are also Thyreophorian dinosaurs, so they're going to have a lot of the same anatomy there from their common ancestor. I'm going to put a little bit more super glue along the bottom part of the lacrimal there. Excellent. Very nice. Very nice. Yeah. There we go. So that's the... What was it? Excuse me. Our lacrimals and our prefrontal, right? So, you saw the lacrimal bone in humans. The prefrontal bone, it might even be like interior to our skull now. Or it might have a different name? I'm not entirely sure. But there we go. The prefrontal right there. This extends over the top of the skull too. You can't really see it at this view. But that's the prefrontal. In humans, it might have a different name, or it might be, like, weirdly inside of our skull. Thank you, FM Rock 2, for the follow. Welcome to Paleontologizing. It should be right here. But instead, you've just got the frontals fused into one bone at the front of our skull. I would not be shocked if the prefrontals were like here, shunted up inside of our forehead. Right about there. Yeah. And the prefrontal cortex is a part of the brain that I don't know if it means that it contacts the prefrontal bone or what. Yeah. Where is the prefrontal bone in a human skull? There we go. It might just be attached to the frontal now. In most vertebrates, the frontal bone is paired rather than presenting the single fused structure found in humans. See frontal suture. And bony reptiles, fish, and amphibians. Oh, in reptiles, bony fish, and amphibians, excuse me, it is often separated from the orbits by 1 or 2 additional bones not found in mammals. So in mammals, I guess those bones have gotten fused on. These bones, the prefrontals and postfrontals, together form the upper margin of the eye sockets and lie to either side of the frontal bones. Yeah. When we're looking at our Stegosaurus skull right here, the frontal bone is going to fit on right there. And that might even be our next step in assembly. We'll see. Let's get rid of some of these tabs.
Hey everyone, this is B.
Yeah. And here, if we want to learn more about skull bones, this might be a nice way to tell.
RegisteredNurseRN.com. And in Anatomy and Physiology, you'll learn about the 22 skull bones, most of which consist of flat or irregular bones that are connected together by jagged suture joints, making it look like a creepy 3D jigsaw puzzle. The 22 skull bones make up part of our axial skeleton, and you can divide them into 2 main portions. You have the 8 cranial bones and then the 14 facial bones. Now here's a quick tip about your skull bones. In the cranial part, those are all going to be single bones except for 2 pairs of bones. But for your facial bones, it's going to be flipped. All of those are going to be pairs of bones except for 2, which are single bones. Let's take a look at the 8 cranial bones first, starting with those 2 pairs of bones. The first pair of bones in the cranium are the parietal bones. The word parietal sounds similar to pair, so that can help you remember that there are 2 of them.
There's 2 in humans. There's 2 in, well, yeah. Tetrapods in general. Yeah. Golganek says the prefrontal is lost in early mammalia forms and is not present in modern mammals either. Yeah, there we go. Yeah. So you can just see it poking out there in red above the eye, in green, excuse me, above the red eye socket. The red sclerotic ring around the orbit. The prefrontal right there. That's... These bones right here are the prefrontals on top of our Stegosaurus skull. So they kind of form part of the eye socket along with the frontal, which is going to fit in right here. That's our next step for assembly. We're going to put our frontal bones on there. These are paired bones. This is the same bone as your forehead. So there we go. This is the frontal bone right here. Your forehead bone. And in us, I guess the prefrontals in mammals, the prefrontals have fused onto the frontals. They're just one bone now. Let's call them the frontals. Or the frontal. This is 2 bones that are stuck together right here. They're paired. It's probably very early in development that they fuse in humans. But in dinosaurs, like Stegosaurus here, you'll be able to see the suture there. Here, let me find that. There we go. See that line down the center, that suture right there? So this is gonna fit in right here. Might require a little bit of cleaning up. Yeah, there's some crud in there. I gotta clean out first before everything will occlude nicely. There we go. I think I got it. There we go. Lovely. There's our frontal, the forehead bone, right here. Excellent. And it fits in really well. Doesn't want to come out. Let's put a little bit of glue on there and get this thing stuck on. Looks like real bone. Thanks, Cyan Streams. Yeah. I've been excited about this. This has been sitting in a bin in my office for I don't know how long now. Probably well over a month. I actually finished printing this, and I've just been waiting for a good opportunity to put it together. And I figured today would be the day. Okay, moment of truth. Let's get our frontal attached here. Beautiful. Really nice fit there. Yeah. Lovely. It's starting to look like a Stegosaurus. Oh, man. Very nice. Very nice. The cool thing about 3D printing like this is if you really wanted to, you could print each of these in a different color. To really highlight these different bones that make up the skull. And one of these days I might do that. I might do like a teaching specimen for my local museum with all the bones as different colors. We'll see. Yeah. Very nice. Very, very nice. Now, next up is going to be go. Working on the back of the skull. So the brain case, the pterygoids, all this stuff in the back of the skull there. The vomer, which kind of forms the roof of the mouth. And then we're going to slot that into this skull assembly that we have right here. And then I think we'll probably do the pre- and post-orbitals and all of that stuff afterward. So I'm going to set this aside for right now as we work on those other pieces. Just kind of let it sit. Let that glue do its thing. Okay. So here we go. There's our brain case. I think there's the occipital condyle back there too. And then I'm not sure what this bone is up top. Let's see here. We've got the frontals there. I guess it's maybe the squamosals and parietals. Anyway, let's find that piece. Have that piece in here. Give me a second. It might be one I still have to clear the supports off of. Hey, look. This is the piece I'm looking for. It still has the supports on it from when I was 3D printing it. I was going to do all the... There's 2 or 3 vertebrae that come with this model. And I was going to do those off of stream. I totally forgot about like our brain case and our occipital condyle and everything. I mistook this for one of the vertebrae as I was getting ready for today. You can see how easy that would be with all of these supports on there. It really obscures the shape. But, yeah. So let me just get this cleaned up real quick. We can get to work on my goggles on just in case a piece of plastic flies up and hits me in the eyeball. My eyes are pretty important to me. I don't really want to lose them. I know I've got 2. So, I guess there's a backup if one of them goes, but I don't want to risk that either. Oh, and hello, Moon Pie. How are you doing? What's going on? No, yeah, I know. Do you want to come say hello? All right, it's our new tradition, huh? Moon Pie on stream. Moon Pie on stream. What plant do I have for you today? Ooh, a cycad. That looks pretty good, doesn't it? Come on over here. Come on over here, Moon Pie. Hey, come here. Come on up. Hey, come on up here. Pretend like I'm ignoring her, and she'll jump right up on my lap. Watch. See? Oh, Moon Pie. Look at what I've got for you. Yeah. Oh. Nice. Yeah. Moon Pie loves feeding on cycads. It's not a real cycad, it's plastic, but she still enjoys it. Huh. Huh. It's a good thing it's not a real cycad. Those are toxic. Toxic for humans and for kitties, and maybe not for Stegosaurus. Yeah. Are we gonna get a new plant every time Moon Pie stops by? I don't have that many plants, but don't tell Moon Pie that. Yeah. I don't know. It's nice to just change them out a little bit. Keep things interesting, even if it's just the same 6 plants on a rotating basis. Yeah. Yeah, it's good to see you. Oh, Moon Pie. Yeah. How's that? Is it good stuff? My goggles? Look, you want to try them on? Here. They don't really go on that way, but here. They kind of go on like this. Yeah. Can I put them on your back? Oh, you don't like that. I'm sorry. Treats. Moon Pie doesn't like treats, Jazzy Cat. He doesn't like them. She's not into it. You're not into it, huh, Moon Pie? He says, that's not for me. I don't like treats. I don't like treats. Huh. Oh. No, you don't. I still need to get a bowl to put treats in. She will eat things out of bowls. Including, like, cereal. It's like if something gets put into a bowl, then she'll eat it. But here's a leftover treat from Sweetie Pie here on the desk. Do you want a treat, Moon Pie? What do you think? No. She says, no, I don't want that. Get that out of here. comes Sweetie Pie over there, too. Let's see Moon Pie start to get a little agitated. Huh. Sweetie Pie's like, what's Moon Pie doing on the desk? I never see her up there. I know, can you believe it, sweetie? Moon Pie's been coming up here all the time. It's been great. What a treat to have Moon Pie here. Yeah. Aww. Your tail's starting to go all over the place like you're upset. What's going on? You want to talk about it, Moon Pie? What's troubling you? What is it? Anywho, I guess I can continue working on the brain case over here, which is made up of a bunch of different bones. Let's continue that if Moon Pie's just gonna hang out. Oh. Yeah, you wanna see? Yeah. Oh, you like the Stegosaur brain case? It's good stuff, huh? Leave it? Alright, I'll see you later, Moon Pie. Thanks for stopping by. And Quiztech, is that a Paleontologizing coffee mug in the background? Yes. Yes, indeed. You can get those on the online merch shop. I guess recommend the mugs. Everything else on there I can't necessarily recommend. I don't know how good the print quality is on the shirts. I'm really picky when it comes to that kind of thing. I'll be hopefully producing some of my own shirts later on this year. I'll be doing a merch drop. I'll be printing a bunch of shirts by hand on stream, if that all works out. But stay tuned for some announcements about that. Hopefully it'll happen before I leave for the field, but I don't know. This spring is shaping up to be pretty busy. So we'll see what happens. Might be an August or September thing. Maybe October. And Pimpcat, yeah, Moon Pie was here. She hung out for like 10 minutes. It was great. That was, oh, we had another cat trick today. How many cat tricks is that so far? Oh no, we haven't had Mini Pie yet. It's not a cat trick yet until Mini Pie gets here. I'm sure we'll have a Mini Pie sighting later on. We'll make 15. Oh, wow, Lenina. Oh, well. Excellent. Let's hope it happens. Fingers crossed. Did we get all 3 cats on today's stream? almost done with this piece. And removing the supports on this is kind of a pain because some of them are inferior, like where the brain would be and the spinal cord. Getting them out of that aperture is, out of that hole is tricky. Almost there. Very nice. Okay. We're good to go. Beautiful. Moon pie's plant. There we go, our brain case. Oh, let's take this off of there. That'll be where it attaches to our cervical vertebrae, our neck vertebrae. Good enough. There we go. So you can see there is the foramen magnum. This is the hole at the back of the skull. We've got the same thing in us. Here we go. At the back of the skull. Right there. The foramen magnum, the hole at the back of the brain case. Human beings are weird. We've got freaky skulls where like our brain case is just incredibly large, freakishly large for an animal. It's nuts. There's the foramen magnum there. So the spinal cord goes through there to get to the brain. Here it is in our Stegosaurus. That's it right there. And then the occipital condyle, where the it's paired in mammals, but that's where your skull attaches to your backbone. Here it is on our Stegosaurus. Ignore that hole right there. That's just there for mechanical purposes because this is a model. There's a plastic peg that fits into that hole. But this is like a trailer ball to attach the skull to the neck. So again, on our baby Triceratops right here, that is the occipital condyle right here. It's like a trailer ball that the neck attaches to. So in ceratopsians in particular, the horned dinosaurs, it really is like a ball and socket joint. These guys could move their heads in all different directions like that, thanks to that really, really robust occipital condyle. You need something like that for such a big, heavy head. Anyway, I'm going to attach part number 8 to the top of our brain case there. So let me find that. And then I'm just going to go on top of there. Just like this. Nice. Simple enough. Let's get it on there. So, see this really scrungy surface? Ugh, that's where all of the supports attached onto it. I printed it in such a way so that it'll be nicely hidden. If one part's got to be all scrungy looking, it might as well be a part that's not going to be visible in the finished product. So I'm trying to be smart about this, you know? So I'm going to throw a lot of Gorilla Glue on here to help just kind of fill that in. One here too. Excellent. And our super glue. We're just about running out of this bottle, which is good. Got a bunch of other ones waiting. Let's stick it on here. Lovely. Beautiful. Make sure it's nice and centered. Excellent. Good stuff. N7 Greeble says, I'm going to look up the oldest dinosaur we found. Well, I can tell you about it right now if you'd like to see. Thus far, the oldest, like, unequivocal dinosaur that we have, most people would say it's this critter, Eoraptor. So this is a little, probably basal sauropodomorph dinosaur from about 232 million years ago, something like that. Not a very big animal. So roughly the size of a big turkey or something. Yeah. So yeah, it's not the first dinosaur. We haven't found the first dinosaur yet. The first dinosaur would unite Saurischia and Ornithischia. We don't have it yet, but this is about the earliest that we've got, is little Eoraptor. I'm learning, says Little Pig Pony. You are. Good job. Yeah. Anyhow. What's the earliest skeleton or fossil we found of any life form? Ooh, that's... Well, skeleton is different from, like, earliest life form. The earliest evidence that we have for life forms is, like, it's chemical stuff. So, like, the actual animals or organisms themselves didn't fossilize, but they would have been very small and bacteria-like, and they would have left a chemical signature on some of the rocks that we have from literally billions of years ago. We've got some of the earliest evidence of life is between 3 and 4 billion years old. And it would have been from simple, single-celled organisms. Which are not good at fossilizing, but they had chemical effects upon their surroundings, which can be preserved in the rock record. So we've got traces to know that they were there without actually having their bodies, because, again, it's really difficult to fossilize single cells like that and identify them and all that stuff, you know? It becomes a lot easier to get fossils of critters once they start to evolve hard parts. It's much easier to fossilize hard parts than it is just squishy nothingness, basically, you know? Not nothingness, but you know what I mean. Cellular equivalent of footprints and stray hairs, basically, Galrox, yeah. Yeah. We'll talk about that another time. I really don't want to dive into that too deep right now, today, because we're trying to get this finished. So let's continue with that. So we've got this step completed, and this is our, I think, our parietals, or squamosals. And then we're going to fit on this part. These might be the pterygoids. Here we go. These right here. Pterygoids, yeah, there we go. So that's this part right here. So that is going to fit on like this here. There's a little bit of support crud inside of these little holes for the pegs, so let's take that out of there. Get that nice and clear. There's 2. Excellent. Beautiful. So there's a little bit of wiggle room here, but I think it's supposed to fit on like that. Let's get it on there. And Sir Keel says, any plans to print a 1-to-1 Triceratops skull? I just did. It's right here. Yeah. A 1-to-1 scale baby Triceratops skull. 30 centimeters long. How cool is that? I just put that together last night. And I'm printing another one right now. Some of these are for friends or for other museums. I've got a little bit of extra filament right now, so I figured it makes sense to do that. Anyway, let's get this assembled. There we go. Just like that. So let's get our Gorilla Glue on there. See if we've got enough super glue left. Yeah, should work. All right. Come on. There we go. I'm just gonna hold that there for a while. Excellent. And to support crud, the technical term, says Little Pink Pony. You know, it works. I don't think there's any nomenclatural code for 3D printing, so as long as people understand what you mean, it's all good. There's no ICZN dictating that. Anyway, yeah. Cool, okay. That's feeling pretty good. So that's this step right here, attaching the pterygoids to our brain case. And now... Step 8. Okay, we're there. Now we attach... Are those the Vomers? Looks like it. Part number 11, I'm pretty sure, are the Vomers. We also have those in our skull. Let's see if we can find them. There we go. That might be the vomer right there. This long, thin bone that's kind of in the middle of the roof of your mouth. Right here. So keep your eye on that right here. On this, and let's play it. So it fits in right there. Pretty sure that's the Vomer. Let's test that hypothesis. Let's look it up. Vomer bone. There we go. Yeah. That's totally it. Yeah. See if this offers any
Hi
elucidation.
there, it's Matt from KenHub, and in this tutorial, we will be discussing the vomer bone. The vomer is a singular bone that runs vertically within the nasal cavity, separating the left and right sides. When the skull is completely assembled, it can only be seen through the nasal orifice anteriorly. This cranial structure runs caudally in an anterior and inferior direction, so that from a lateral point of view, it looks like a diagonal rectangle.
So is this the same one that I was looking at here? There. Yeah. Single bone right there. Yep. That's totally it. Nice. Now, what does it look like in our Stegosaurus? Looks like this. Longer and thinner than ours, but Stegosaurus has got a longer and thinner skull. And you can see how it kind of... I think this is at the... Well, I guess this is caudally. It kind of forks. In humans, it forks at the anterior part a little bit. Not really in the back, but yeah. Whatever. We're going to attach this part next. So that is going to go on right here. Just like that. Ah! Should have waited for that to dry properly first. Alright, we're going to give this another minute over here to dry, and then we'll attach our Vomer. Anywho. Claire Burr says the instructions could be worse. Sure, yeah. Yeah. Or like if you're drawing an owl, you know? Oh shit. Stay there. Step 1, draw some circles. Step 2, draw the rest of the owl. Yeah. I used to have a lot of those, well, not a lot of them. I had one or two of those how to draw a dinosaur books when I was a kid. And they would usually have you start off with circles or ovals or triangles. It's like, you draw this series of triangles, you know, in order to draw your dinosaur. And it never helped me at all to do that. I would just try and copy, you know, the last step. And, yeah, I'm kind of convinced that it's not a great way to teach drawing, necessarily. Anyway. Still on step 1, but someday, says Gowrox. Yeah. Anywho. Our Vomers. We might even be able to attach the Vomers later. I don't know if it really makes sense to do it right now. Trying to follow our instructions here. Let's look through later on in the instructions and see if that's really that necessary. Because it wants us to put the Vomer on before we slot the brain case on to the skull. So here's our skull. Let's just try and put this on and see if it's possible to put the Vomers on later. Yeah, it should be. Don't see why not. Yeah, and look at that. It's coming along. But, well, let's try and follow the directions if it's at all possible. I'm going to put a little bit more glue along that part there, because I want to have a really strong connection. There we go. Great. All right. I'm real careful. Oh, already pooched it. Never mind. Forget I said that. We just gotta wait for this to dry for a second. Anywho, let's see. Let's talk about Stegosaurus for a minute here. Not a lot of great videos on Stegosaurus. But the best we're gonna do once again is PBS Eons.
Doing very much. Maybe.
Let's take a look.
If you dig through your nearest toy box, you'll find some pretty familiar forms of ancient life. You got your Triceratops, you got your Tyrannosaurus, and one of my personal favorites, the Pachycephalosaurus. But you know the one animal in here that doesn't quite belong? The one that's doing its own thing? The Stegosaurus.
Yeah, so Tyrannosaurus, Triceratops, Pachycephalosaurus, they're all from the same time in the same place, you know? They're all from the latest Cretaceous Hell Creek Formation. So you might even say,
And they were roommates.
Oh my god, they were roommates.
They lived at the same time in the same place. They're coeval. They shared the same environment. Triceratops, Pachycephalosaurus, Tyrannosaurus. They're all from the Hell Creek Formation. They all live together in this environment. And in... They don't have Pachycephalosaurus in this one, but... you'll see images of them all together. There we go. Tyrannosaurus, Triceratops, Pachycephalosaurus, all here in the Hell Creek. Yeah. Tyrannosaurus, Triceratops, Pachycephalosaurus. Lovely illustrations here. This is beautiful. Oh, and holy cow, number 2, there's Trirarchuncus. Lovely. Oh man, this is fantastic. I really dig this. Here's an image there for you. Anywho, Stegosaurus. Stegosaurs lived during the late Jurassic.
If you take it as a given that extinct dinosaurs were all weird and wonderful, then you gotta at least consider that Stegosaurus is one of the weirdest and wonderfulest. Stegosaurus is the most recognizable genus of the Stegosaurids, four-legged herbivores that sported bony plates and spiky spines in their backs, earning them the name that...
Who did these illustrations? We know these are not accurate restorations, but they are adorable. I suppose that's well, that might be up for debate, actually.
Means roofed lizard. But unlike the other dinosaurs you find in your toy box, which lived in the Cretaceous period, Stegosaurids hit their prime a lot earlier in the Jurassic. This is when some of the biggest herbivores like Diplodocus roamed the Earth, while carnivores like Allosaurus had just come on the scene. It was in this environment that Stegosaurus thrived with the help of some awesome adaptations. But in some ways, despite all that armor, it might have been a little under-equipped because its brain was almost impossibly small. Stegosaurus had one of the lowest brain-to-body ratios of any known dinosaur. The animal itself can grow up to 9 meters long, about the size of a small bus. But his brain was only about 60 square centimeters, the size of a puppy's. And when I say that this was almost impossibly small, what I mean is for a century or so, some paleontologists actually thought that Stegosaurus must have had a second brain in its butt. In the 1880s, Yale paleontologist O.C. Marsh found that some specimens of Stegosaurus had a big cavity in its sacrum, where the spinal column meets the pelvis. And he figured since the brain in the head probably wasn't doing very much, maybe Stegosaurus was getting some help from its, for lack of a better word, butt brain. This led to a pernicious myth that Stegosaurus had, if not an actual second brain, then at least a separate bundle of nervous tissue that helped control its tail and legs. We know now, of course, that Stegosaurus did not have two brains, and some experts think the cavity in its sacrum was actually used to store glycogen, the starchy compound that animals, including you and me, use to store energy. And just because his brain was small, that doesn't mean Stegosaurus was stupid. In fact, he didn't want to tangle with this thing, because it had a secret weapon, the Thagomizer. That's the unofficial name for the dinosaur's spiky tail. Not all Stegosaurus...
So it's an informal term. It's not really something that you see in a lot of published papers. It's in a few of them, I think. But that term Thagomizer, is he going to talk about where it came from? Maybe not. This is a classic bit of fun trivia. It comes from the Far Side cartoon by Gary Larson. There we go. I'm trying to find you a decent image of it. That'll work. So there's a caveman giving a presentation to his comrades here, pointing to the spiky end of the stegosaur tail. He says, "Now this end is called the Thagomizer, after the late Thag Simmons." Yeah. That's where that term comes from.
It's had Thagomizers, but for those...
So anyway, that Gary Larson made that comic, and then there were a lot of scientists who were, you know, really enjoyed the Far Side. You'd see it, you still see it on a lot of, you know, professors' office doors and stuff like that. You'll see it in scientific laboratories, you know, pinned up on the wall. And I think it was Ken Carpenter, paleontologist who used to be at the Denver Museum of Nature and Science. And Ken actually started using that term in various talks, and I think in a few published papers. Yeah. Open Out. Thank you for the raid. Welcome to Paleontologizing. Holy cow. How are you doing?
Out and their 17 raiders are about to get flattened by dinosaur content.
Welcome, welcome. Flattened or maybe perforated. Talking about stegosaur tail spikes. Welcome, welcome to Paleontologizing. Open Out. It is good to have you here. Hello to you too. How was your stream? I hope it was really good. You're doing some food and drink. Awesome. We are doing some dinosaur skull assembly right now. Putting together a life-size 3D printed Stegosaurus skull right here. So you see we've got the front of the snout, nostril. There's going to be the eye socket right here. There's the teeth. I'm waiting on some bits of the brain case and associated bones to finish gluing. Waiting for that glue to set up. So we're watching a quick video on stegosaurs. Still need some time. Yeah. Did an IRL stream at work? Very nice. Making pretzels all day. Excellent open out. Oh man, I love soft pretzels. That sounds so good right now. I hope the pretzels turn out great. Thanks for rating in. I appreciate it. Welcome, welcome. Oh, and look who it is. If it's not Miss Minnie Pie, we might have another cat appearance here. That would be all 3 cats in one stream. You know what we call that? Cat trick. Minnie Pie, hello. There she is. Hello, Minnie Pie. How are ya? What's shaking? Does it smell like super glue up here? An interesting smell? Yeah? Very nice. Very nice. Yeah. Now, you came here for some treats, didn't you? You found one. Look. Sweetie Pie left a treat there. You're not going to eat it? All right. Let's get you some fresh treats. Let's get you some fresh treats. Oh, ho, ho, ho. Ho, ho, ho. There we go. That's the good stuff. That's the good stuff. Look at all those. That's too many. It's too many treats for you. No, you're not going to eat all those. Tasty, tasty. All right. What do you think? She's like, I'm not that hungry, but I guess I'll eat them. Why not? Why not? You know, when in Rome, eat some cat treats. Anyway, it's great to have you here, Open Out. Thanks for bringing your viewers. It's good to see you. And Inachu says, I would like to see AI being used. Ugh. To make a video to show all of the evolution missing links. I mean, it's going to show you, but AI is not good for real information. It makes stuff up, you know? It's like glorified autocorrect. But she didn't finish all of them. Anyway. I'd much rather see a skilled animator do that, like an actual human being with a brain, rather than some error-prone computer model. It's just gonna hallucinate some garbage. Yeah, and like I'd like to see it produced with the input of a paleontologist. That would be something real and cool. Don't give me that AI dog water. Ugh. Ugh. AI pictures of dinosaurs are notoriously terrible. It's just complete garbage. Like excrement. So yeah, I don't know. Ugh. Yeah. Parkers and Quinn says, yes, exactly that. Support real people /art. Absolutely, yes. There's so many very talented paleo artists out there who are struggling to make a living. And now people want to, you know, it's like... I don't know. They deserve to be paid for the excellent work that they do, rather than just people settling for just the most disgusting, artificially generated slop, you know? I've got an extremely low opinion of all this AI. I'm struggling not to cuss. Put it that way. Ugh. And plus it steals art. Exactly, Ms. Art Rules, yeah. AI art stuff, it's just automated plagiarism. It's taking real people's art, training the model on it, and then just spitting out an inferior product. I despise it. I detest it. It's disgusting. Anyway, yeah. Yeah. That said, let's get back to a video here produced by real human beings with actually good scientific information in it, you know? Yeah.
Those that did, like Stegosaurus and Kentrosaurus, fossil evidence shows that they were very effective weapons. In 2014, the study of an Allosaurus fossil from Wyoming showed that
We talked briefly about this earlier.
A puncture wound that matched the spikes on a Stegosaurus tail. Researchers concluded that the Allosaurus had attacked a Stegosaurus, which landed a blow right in the predator's groin. The wound became so badly infected that it killed the Allosaurus, and the fossil record preserved was probably the most gruesome groin shot ever documented. Now, I'm sure you're wondering about the Thagomizer's name. Well, in 1982, Gary Larson's comic strip, The Far Side,
telling you about this.
A group of cavemen getting a lesson in dinosaur anatomy. And it shows the weaponized tail of the Stegosaurus labeled as a Thagomizer, quote, after the late Thag Simmons. Okay, I know what you're gonna say. Cavemen and dinosaurs did not live at the same time. But the point is, the name stuck. By the 1990s, paleontologists actually started referring to this tail feature as a Thagomizer. And when I interviewed Dr. Robert Baker, the researcher who studied the Wyoming Allosaurus, he assured me that the Thagomizer is an accepted term for a Stegosaurid spiky tail. Now,
it's been used before. It's not like the official term. It's not an official anatomical term, but it's used informally, for sure.
By far the most recognizable parts of a Stegosaurid are the bony plates along its back, often called
Do you
scutes.
think dinosaurs are put together correctly? The bones. You're smart. What do you think?
Do a research on that, Oliver.
I never.
GM
Smurfette, thank you for the follow. Welcome to Paleontologizing. It's good to have you here.
Scutes, by the way. I looked it up. Scutes. And even when
the most extraordinary group of animals that have ever appeared.
Jonathan Adshead.
The dinosaurs.
Or is it Adsheed? Thank you for the follow. Welcome to Paleontologizing. It's good to have you here.
Bony plates along its back, often called scutes. Not scutes, by the way. I looked it up. Scutes. And if you want to start a real brawl among a bunch of paleontologists, just ask them what those scutes were.
Rapunzel says AI isn't just Gibrauch. I'm sorry, I don't speak German. So much stuff that machine learning can bring to academia. Sure, but it's got very limited applications, and that's not the stuff that's going to end up making money. That's my whole problem with AI, is that people with no talent but a lot of money want to use AI to take the jobs of people who have the talent but don't have money. You know, basically to automate artists out of existence in a lot of cases, automate writers out of existence, musicians, people who pour their hearts and souls into learning a skill, learning a craft, becoming artists, you know? And people who are, you know, they've got this finance brain disease. They don't want that to be a thing. They're like, oh, you know, I don't appreciate that art or those people. You know, we can automate this, you know? Let's think about the bottom line here. You know, there's money to be made. There's profits to be had. To heck with all of that human creativity or artistry, you know? That's what I'm talking about here. Where, yes, there are niche applications for artificial intelligence. Even the term itself, I'm kind of uncomfortable using it in a broad sense, but like, I wouldn't call it intelligence. It's a glorified autocorrect, you know? That's what I'm talking about. Like, yes, you can use AI if it's trained on good information. You can use it to help summarize things. You can use it to help save time. You know, those kinds of rote tasks that are very time consuming. Sometimes you can kind of automate those, but, but that's not what a lot of people are trying to use it for. They're trying to use it to automate human endeavors, human creativity, artistry, that kind of thing. And I rankle at that. That makes me sick, you know? I think that's primarily what people are trying to use it for. There's a few academics who are using it for cool things, and that's really neat. We'll hopefully be talking to one of those people pretty soon, actually, about a really neat project that AI was used for. But oh man, the commercial applications of it are really gross. So yeah. Anyway, let's continue.
Because they are still some of the most hotly debated features in dinosaur physiology. For a long time, it was argued that the scutes were there for thermoregulation. In the 1970s, researchers found some...
And so, what we call these dorsal plates or osteoderms. I've never heard stegosaur plates be described as scutes before, but...
tubes running through some fossilized scutes, and thought maybe they circulated blood through the plates to radiate heat. But not everyone agrees with this. Some experts have pointed out that not all stegosaurids had a lot of scutes, so if they did give them some advantage, they'd be more common. Others have noted that the tubes don't actually run all the way through the plates, which they would do if their job was to circulate blood. Now, you might also think that the scutes were defensive, but if that were the
Again, the use of the word scutes bothers me a little bit, because we don't call them scutes. We call them plates, or osteoderms. But that's a good point, though, that if they really were used for thermoregulation, kind of like the fins on a radiator, in radiators, there's a tube that goes up and then down. So it goes around. With the stegosaur plates, the osteoderms, the blood vessels don't do that. Here we go. The grooves on a stegosaur plate... there we go. This is the figure I was looking for. From Museum of the Rockies. This is on display in the Hall of Giants, their big Jurassic and early Cretaceous hall. The grooves go up and then they stop. They don't loop around.
Raptor is the most dangerous dinosaur around.
Hazanku, thank you for the 33 months of support. I really appreciate that. Yeah. Good stuff. Good stuff. Thanks for keeping me online, Hazanku. I really appreciate it. So yeah, some of these kind of fork, they branch, and then they go out and they terminate. None of these goes up and then back around. None of them forms a loop, which is what you would probably expect if this animal were circulating blood over the plates in order to cool itself or warm itself up. You just don't see that. This seems much more consistent with just blood vessels that help nourish a keratinous sheath over the top. So keratin is a structure that a ton of different animals utilize in order to build big structures on their heads or on other parts of their bodies. The horn of a rhinoceros is made of keratin. The casque on a cassowary's head is keratin as well. Keratin is often very brightly colored. If these were used primarily for display, which is what I suspect, then those blood vessels going to supply a keratin sheath would have allowed this to be really brightly colored and really showy, you know?
Okay, some experts have asked why they only appear on the back and not on the sides or on the skull. The most recent theory is that stegosaurs had scutes because they just looked awesome. After all, modern day birds have made a very good living by having a lot of features that are just for display. So why couldn't the same be true for extinct dinosaurs? In 2005, a paper from Berkeley suggested that the plates helped the dinosaurs tell one species from another. 10 years later, another study from Princeton proposed that the plates were even sex-specific, with females having tall, skinny plates, while males sported bigger, broader ones. But again,
I think nowadays the idea is that these are different species or different genera. Stegosaurus versus Hesperosaurus. Yeah, but there's not a lot of people working on stegosaurs, so it's not like we've got these ideas being tested all the time, left, right, and center. It can be years in between, like a rebuttal paper, or the initial paper and then a rebuttal paper or something like that. Like, there's not a lot of people who work on stegosaurs.
But again, not everyone agrees. What I think everyone can agree on is that stegosaurs are famous for good reason. They might not have had the biggest brains, but they cut a distinctive figure for themselves back in the Jurassic with their scutes and their thagomizers, which they knew how to use.
And there you go. Yeah. Good stuff. And this is... it's just about secure enough that we can attach our vomer bones onto it and move on to the next step of our assembly. So I'm gonna make sure that those pegs actually fit into where they're supposed to. Put this down a little bit. There we go. There's our Vomer right there. And clear this out a little bit. And Brain Spike says, Claire, so this is not, it attaches to the brain case, but this is the roof of the mouth. We looked at this earlier on the human skull, remember? The Vomer bone. You'll see. Just clear this out a little bit more. I want to make sure I get a really good fit. There we go. Good enough. All right. We want a quick bond here, so I'm just going to do pure super glue, just cyanoacrylate for this part. There we go. And I'm going to hold this here until it starts to set. It's going to take a minute. Anyhow. And Pendrake says maybe each plate had a big frill of feathers on it. We don't have any evidence of feathers in thyreophorian dinosaurs, in our armored dinosaurs. So we've got no reason to think that they had feathers. It's possible. It's certainly possible. But thus far, we've got no indication that that's the case, if that makes sense. Anyhow. Boy. I'm tempted to go grab a clamp to kind of hold this in place while the glue sets, but I think it should just be another couple minutes, and we should be golden. Anyhow. Again, we're at this stage right here. We've got our Vomer attached to our brain case, attached to the pterygoids right there. I think those might be the ectopterygoids, actually. And then we're going to attach the back of the skull to the front of our skull. And I think we're ready. Let's do it. Yes. Here we go. This is gonna fit in just like this, and just like that. Gotta be really careful because there's delicate junctures between these, especially with the glue not totally set yet. But ideally, we should be getting it in there before the glue is totally set, because it will have to flex a little bit in order for everything to fit together. The Vomer goes on top of the maxillae, right? I think so. Yes. Yeah. Okay. So what I'm going to do here is put some glue in here, and we'll get ready to put this thing together. That's the right one, right? Yes. And there's an endopterygoid. There might be. It might also have a different name. I don't think there is, actually. I think it's just the pterygoid. I don't think there's an element called the endopterygoid. Alright, that's it for that. Super glue. Let's open a new one here. There we are. Lovely. Look at how this is going to occlude on there. So I'll put a little bit of glue along here too. That should do it. Okay. Moment of truth. Put this together. So I'm gonna make sure the vomer fits up over the maxillae. And then put this on here like that. There we go. Nice. Very nice. Excellent. Beautiful. Oh, that's really nice. So I'm going to hold this here for a little while and wait for that to set, and then we'll worry about the distal end of our vomer, and we'll get that hooked on, and that'll give this whole thing a little bit more structural rigidity so it won't shake apart. Again, the vomer, this long, thin bone right here in the center. See that one in there? We've got that too. Kind of on the roof of our mouth. It's very, very thin in people. It's right here on our... Oop, right here on our Explodo human skull. There it is. See how thin it looks in... from a ventral view like that. There it is here. Yeah, you can barely see it. It's right there in the roof of your mouth. Yeah, keeping track of it right here. And then when everything comes back together, it's just kind of locked up inside there. The vomer. Yeah. Right there. And here it is in Stegosaurus. Pretty cool. Pretty cool. And Mayor Space's warning, do not explode your own skull. This is done by trained professionals. Yes. Oop. And I'm a bit nervous about how this is moving around. But if we put just a little bit of glue on there, Well, I'm not going to worry about that at the moment. What I'm going to do is... carefully set this down, and we'll see what our next step is. I think it's going to be some of the bones around our orbits, our eye socket. So it'll be the postorbital, the jugal, bones like that. Okay. Lean this up over here against the wall. Nice and stable. Excellent. Let's see what we got next. So there we go, yeah. That looks like our jugal right there is going to fit underneath the eye socket. Just like that. Let me find that bone. It's got that big flange. That's definitely not it. There we go. Yeah, that can't be the jugal. What is that? It's too small. No? That looks like the jugal. It's so thin in the model. It looks much thicker on this diagram right here. So your jugal is, well, I'll show you on the human skull. But yeah, there it is right there. Although it almost looks like it's interior to the jugal. That's the right one. Doesn't really articulate there though, like it's supposed to. I think we skipped a step. Good thing is there's no time crunch right now because we should be waiting for those things to set. I almost feel like we missed a step with the top of the eye socket. So number 6 and 5 right there, forming the upper margin of the orbit. Got that open peg right there in step 10. Still open right there. A little bit confused by that. Number 12 fits on there. Just like this along the inside, so it connects up to that portion of the maxilla. Just a second here. So, trying to figure out which piece goes on right here. Our instructions say it's this bit, but there's not really a good place for it to fit on. I don't think I'm supposed to just hold it in place while it dries. That doesn't quite seem right. There's a little plastic peg right here. Maybe I've got the left side, or the right side instead of the left side. Look through the rest of these pieces. There we go. Maybe it's this one. That does look more like it. Looks like it's supposed to fit on like that, but that doesn't make any sense. Bear with me here as I figure this out. Is the right piece? Okay. It's supposed to go on just like this. I just gotta find the right orientation for it. There we go. That's it. So it should fit on. I'll show you what I'm working with here. This is going to form the lower margin of our eye socket. So it should fit on just like that, but do I put it like this? Do I put it more oriented outward? How do I do that? When I was looking at this right here, this step here, this is really confusing because this angle doesn't really show me. Is this flange contacting the ectopterygoid right here? Excuse me, the pterygoid right there? Or is it not? I can't tell if there's daylight in between this piece and this piece. It doesn't look like there is. And I'm not sure how to get that to work with this piece right here. If that makes sense. Yeah. It's tricky. It's very tricky. So I'm kind of tempted to just skip that step for right now, and I think that's what I'll do. It'll become more obvious later when we get some other pieces on there. One of those parts that should be really easy is this right here, part number 15. So these are our squamosals, right? I think so. What are those? Right here. Parietals are up there. Squamosals are up here. Oh shoot, what are these called? Gosh darn it. Is it the basioccipitals? Yeah, there we go. Dials there. I don't know if we're gonna find it for a stegosaur, but we'll try it. Stegosaur basioccipitals. It's not gonna show us, is it? Let's try Tyrannosaur. Yeah, there we go. It's almost like butterfly shaped or something. It's got these lobes that come off the sides of it. Those are our basioccipitals. Let's stick those onto the back of here. And make some progress. There we go, right there. So that should be a pretty easy fit. Just like that. Excellent. And I'm a little bit rusty with my ornithischian dinosaur osteology, like cranial osteology for ornithischian dinosaurs. It's a nice little refresher for me today. Oh, and I'm concerned that this is coming off here. And gamer girl me, how are you doing? Hello, hello. Welcome to Paleontologizing, or welcome back, I should say. How have things been? It's good to have you. Thanks for bearing with me, everybody, while I get a little bit frustrated putting this together. Nobody said that assembling a dinosaur skull was gonna be easy, even a 3D printed one. But it's cool that we get to hang out here and talk about cranial anatomy, talk about these different bones in the skull. These, how they're the same bones that you have in your own skull. Pretty neat how that works. Alright. Okay, let's work on getting that basioccipitал on here. Go. So we got some gap-filling Gorilla Glue on there. Now let's throw some super glue on for that quick, tight bond. Excellent. Out of here. There we go. Nice. All right. Excellent. There we go. There's the back of our stegosaur right there. Stegosaur skull. And so you can see where the spinal cord would go through. Not the square hole. That one's just a peg for attaching the vertebrae, because this is, again, a 3D printed model. But the round hole on top is what we call the foramen magnum. So that's where the spinal cord goes through to get to the brain. We've got the same thing on our skulls, like I showed you a few minutes ago. Excellent. All right. Looking good. Looking very good. May I share what they found at a quarry in a town not far from me? Go for it, gamer girl me, yeah. Okay. And now we're gonna do, let's see here. Other bones that we need to attach are gonna be our jugal, our quadrate, our quadratojugal, and our squamosal. So let's see what's next. Part number 17 right here. looks like our post-orbital. Okay. And then the super-orbital is going to go over the eye. Let's go ahead and find this piece. Our post-orbital here. There you go. Now you can see. Right there. Kind of an L-shaped bone almost. Or Y-shaped, depending on how you look at it. Should fit on. Nope, not like that. Well, this is after the superorbital already went on. We gotta put that part on first. Superorbital should go on. I almost feel like they skipped that step here. There we go. Let's just put that on. Okay, excellent. Now we're cooking with gas. Let's set this down for a second. So that glue continues to set. And gotta clean up this peg a little bit so it'll actually fit into the hole. Nice. Yeah. So that's going to fit on right there. This is above our eye socket. And then there's this other piece. Our post-orbital here. Gonna fit on just like this. This peg needs to be cleaned up too because it's not fitting in properly. Let's do that. There we go. That's the kind of fit we were looking for there. So our post-orbital and supraorbital, we are going to fit together here. Let's see how those line up again before we actually put any glue on. Our post-orbital, just like that, and our supraorbital over the eye socket goes right there. So what I want to do is get the post-orbital on first. Let's start gluing that up. And thank you, Sergeant Major Dilemma. What a great name. Welcome to Paleontologizing. It's good to have you. Thanks for joining us. Alright, that's on there. Feeling fairly secure already. That's heartening. Good stuff. Okay. Now comes our supraorbital, which should slot in right there. Both of these kind of need to go in at the same time, which is a little bit frustrating. So let's see if we can make that happen. There's like an interesting angle of approach. I gotta pop that up and onto it. There we go. Lovely. So there's the upper rib of the eye socket, the supraorbital bone right there. Now we as humans, as mammals, don't have this anymore. It's basically like become part of the frontal bone, as I understand it. But got it there on our Stegosaurus. Nice. I just gotta hold this here for a minute while it dries. But I'm pleased with how this is going so far. And it's big. When I printed this other Stegosaurus skull years ago, the super basic low-res one, I thought I had goofed up and printed it a little bit too large, and it turns out I had. But that's not bigger than a real Stegosaurus skull would be, necessarily. It is bigger than that particular skull is in real life. But it is... it's not too big for a Stegosaurus in general. And we actually encountered this skull in the wild, so to speak. That would have been... was it Western Wyoming Community College? Search. Wyoming. So it would have been at the beginning of last year's fieldwork in Wyoming. Where did that go? Here, I can get to it if I go to the playlists. And we'll do summer 2023 fieldwork. The first one of these, well, okay, it's not actually in this playlist. There it is. Yeah, this is what I was looking for. Yeah, but yeah, just thought I'd show you this. And I'm really impressed with just the closer you can get to skeletons like this, the bigger they look. There's that same skull right there. Impressive. So this is the same skull that I actually have in my office, although I'm now realizing I printed mine too large. This is the actual size for these here. Yeah. There it is right there. Yeah. So this is the University of Wyoming Stegosaurus specimen they've got over in Laramie, I believe. But yeah, it is a big animal. It's
a lot of things about this skeleton that we would change nowadays based on what we know
And
about
Wymit34, how are you doing?
For
Hello,
instance,
hello.
You've got that tail dragging along the ground right there. We might have too many dorsal plates, too. I counted 21 on this earlier. I'm sure they probably vary. I wouldn't be shocked if Stegosaur plate number actually varied between individuals of the same species alive at the same time. But yeah. Not the beast says that is a small skull for a creature that size. It definitely is. These were probably not, grazers walking around, just hoovering up all the plant material in sight. These guys are probably pretty selective feeders. You can see how narrow that skull is. Probably pretty picky eaters.
Very choosy.
Yeah.
Precise about which plants they're picking up.
Yeah.
Not just shoveling everything into their mouths indiscriminately.
There is he. Very gently. Boop. Yeah. Stegosaurus. It's funny, too, the scaps and the scapulae are mounted really far forward, which makes the animal's neck look really, really short. These should actually be a little bit further back, I think. Because stegosaurs like this, they've actually got, not the shortest of necks. And the neck would probably come up at an angle, too. Like, not low slung like this, but probably a little bit more upright, more alert looking.
Anywho, that's what we're working on assembling right now. Ugh. Stegosaurus skull. Let's see which bone we want to put there behind the post-orbital. Again, it's tricky to hold this and keep it from falling apart and move around my cameras and microphones and computer mouse and everything else. So we'll find this bone right here, which is going to be our squamosal back there. That attaches to the post-orbital. Post-orbital and squamosal. The squamosal step was further back. There we go. This guy right here. Yeah, let's find that. There we go. What's tricky is that all of these bones fit together in just such a way that you kind of can't avoid knocking some of them out of place when you put another one in. Ah, goodness. You get that happening. So let's put this one on, and then the one that fell off, we'll reattach it. So we're sticking our squamosal bone on right now. Let me clean up this opening just a little bit so the peg fits in better. That should do it. Kind of crazy that I'm doing this in front of a live audience. This is the sort of thing that requires a lot of concentration and precision. I shouldn't be juggling a dozen different tasks at once, but hopefully that makes it a little bit more interesting to watch. The whole point of this is science outreach. Getting people excited about science. Hopefully this is at least kind of fun to watch. Seeing a dinosaur skull be assembled before your very eyes. I like to think there's something inherently cool about that. Alright, a little bit more Gorilla Glue in here. There we go. Nice. That's a good fit. Okay, excellent. Sometimes you really need that Gorilla Glue to kind of fill in those gaps. Just provide some volume, you know? Speaking of which, let's get it on here, too. There we are. Beautiful. So see how all of these fit together so intricately?
Armored giant, wreaking his prehistoric fury on modern man and his puny machines.
Lapdog Millionaire, thank you for the follow. Welcome to Paleontologizing. Here. Look right here. You've got your supraorbital, you've got your postorbital, you've got your squamosal, and these fit together right here. Got a nice little suture between them. Suture between the supraorbital and the postorbital right there. Just these, I'm not going to call them delicate connections, but you know, they fit together like puzzle pieces. There's an intricacy there that I think is really interesting anatomically. It's just how skulls work, you know. And I'm going to put a few more spots of glue here and there. Just try and keep this wobbling too much. Those set up properly. Then make my life a little bit easier. Beautiful. And right there, you can see where these different bones join up, and there's an opening in the middle. We call that the temporal fenestra right there. We're going to have another one on the other side, too, once we get that assembled. So that's the temporal fenestra. We don't have that anymore as humans. I don't think a lot of mammals have lost that entirely. But most dinosaurs still have a temporal fenestra. Most, if not all, dinosaurs. Some ankylosaurs may close that up. Some of the pachycephalosaurs might do the same thing. It's at least highly reduced. Very cool. Yeah. Anywho. And Rushwing says, would all of those extra delicate bones give it a bit more flexibility? Would it make it take impacts better? Not really. It's just those are the bones that were there in the ancestral form, in the ancestral condition. So they're not extra. They're just, that's kind of the default. Mammals that don't have some of these bones anymore, like that's a weird derived trait. It's like a special thing that they evolved to no longer have those bones there. Does that make sense? Yeah. You can go back to more basal vertebrates, so to speak. Things like bony fishes. Let's see if I can find this for you. Yeah. The skull of a bowfin fish. There's a bunch of the same bones, and then there's additional bones. Things like the opercular and subopercular, interopercular, the supramaxilla. Yeah, all these bones at the back of the skull that tetrapods don't have. And I don't think they're analogous to tetrapod bones either. I think this is just something that's in bony fishes, but not in tetrapods anymore. Yeah. Does that make sense? Yeah. So the point is, sometimes as you get further and further from those fish ancestors, you kind of do away with a lot of those bones. You just don't really need them anymore. Those were like the ancestral condition, and well, being unnecessary, they get lost through evolution. So Stegosaurus has got fewer bones in its skull than its ancestors would have had. Stegosaurs go extinct sometime in the Cretaceous period before the end of the Age of Dinosaurs. So evolution stopped for them. But if they'd continued to evolve until the present day, you would probably see a further reduction in the number of skull bones. Just like a lot of the later dinosaurs, as they become more derived, sometimes some of those bones that were present or prominent in their ancestors become reduced or even absent. That's very true for mammals, too. Having evolved from an amphibian ancestor, the proto-mammals and then the true mammals, they're kind of continuously modifying their skulls and making them, in some ways, kind of ever more solid, and fusing certain bones together. Like we as humans, our temporal bone, our frontal bones are just one bone now, kind of on our forehead. In our ancestors, there was a suture that ran across here. 2 bones paired. Now it's just one frontal bone right there. Does that make sense? Yeah. Anyway. Very cool stuff. Let's move on to the other side and do some of those bones. I'm gonna put our what's this disposal back in? What's this? Yeah, let's do it. Set this down. Set that down the other way, because that vomer needs to be oriented downward. Uh-oh. See, this gets tricky, because there's all these different parts that are super delicate, and when the skull is not fully together, you're putting stresses on certain parts, it kind of wants to disassemble on you. I'm trying not to let it do that. I'm just gonna hold it here like this. Let's attach this bone to the back. Is the T-Rex skull finished? No, it will not be for a couple months, Jesse Vanitas. I've still got a bunch of parts to print on that. And, yeah, and it'll take a good while to assemble. I'm going to be doing most of that off-stream because it's just too big. Like, it won't be able to fit into the frame. The Stegosaurus skull barely fits into the frame as is on stream. And this is a critter with a small head relative to its body size. The T-Rex skull is over 4 feet long. It's well over 1 meter in length. There's big portions of that I will not be able to assemble on stream. Yeah. And humans have fused a lot, and I guess I was curious what could have caused that. That's just a thing in our mammal ancestors. Mammals seem to really like fusing their skulls up. It might have something to do with, you know, the majority of mammal evolution was back in the Mesozoic. Mammals evolved at around the same time that dinosaurs did, during the early part of the Mesozoic era. And mammals were very small for the majority of their history. And they didn't need to have like big weight-saving measures in their skulls or anything. You could fuse them all up, have them be really boxy, almost kind of overbuilt. And it didn't matter. And that might be something that kind of continues into today. Mammals are just sort of continuing that tradition. Those are the cards that they were dealt, and they're playing them, you know. That might be why. Well, that is one of the reasons why mammal skulls are so kind of overbuilt and seeming when you compare them with, say, dinosaur skulls. Looking for my post-orbital bone. There it is. It's on the ground. And XVR says, I always thought being born without the skulls being fused, separate bones, might be easier to, might be more advantageous for live birth. To a certain extent, sure. That's one thing that you see in maybe humans, is that some of the skull bones are not fused up yet. You get that open fontanelle, that opening in the top of the head for baby humans. I think that is thought to have something to do with birth, like it lets the head squish a little bit to fit through the birth canal. At least I've got a vague recollection that that's the case. Could be a just so story, but I think it has something to do with that. And Dilbot says, will this skull be displayed behind you? At some point, yeah. Yeah. Maybe tomorrow, actually. Once it's assembled. But yeah, I change out the backgrounds for every stream here. So what you're seeing today is largely Stegosaur-centric. There's a lot of Stegosaur stuff going on. For today, Stegosaur plate, Stegosaur tail spike. There's the Stegosaur skeleton at University of Nebraska at Lincoln. Here's my old Stegosaurus 3D print. And then we're going to be talking about horned theropods later on today, too. So there's that. But yeah, I strive to have different backgrounds for each stream. Always want to keep things visually interesting. As best I can. Fossil science doesn't stand still. It's always changing. We're always learning new things. I want my stream background to reflect that as best I can. Alright, let's put some glue on here. Just like that. Okay. Glue on here. And glue on there. There and there. Okay. Alright. There we are. Excellent. Good stuff. Just gotta hold it while the glue starts to set. And you can see now both of our temporal fenestrae are complete. There's two openings right there. And is an individual spike called a thag? It's definitely not, DM Wing, no. Never heard anybody say that. In fact, thagomizer itself is an informal term. It's a fun one. You will occasionally see it in the scientific literature, but I think it's only occasionally. It's kind of rarely used. It's mostly a fun term that we have. It's not like that's super official or anything. Anyhow. your post-orbital bone. Yeah, I forget if we have that one or not, Damwing. If it might be fused onto another bone. It might be something that's kind of not really a thing anymore in mammals. Okay, that's on there. Now the supraorbital. I'm gonna put on right here. Let's get some glue on there. On and let's get that piece on there. Nice. Lovely. All right, beautiful. Look at that. So we've got our supraorbital, the bone over the orbit, the eye socket, right here. Now we've got it on both sides of our Stegosaurus. Lovely. Beautiful. Excellent. Did you know they found the fossil of the meteor from Morrocoin? Well, I mean, the meteor is the light phenomenon. It would be the meteorite is the actual object. But interesting. Wait, is this a new thing? Did this just come out, Claire? Back in 2006. Okay, yeah. I thought we had some pieces of it, which is how they could tell for certain that it was from an impact and it wasn't something else weird going on. Yeah. Very nice. Who is this?
Dinosaurs were the sort of creatures you might think of as inhabiting another planet. Or the kind you dream of in a bad nightmare.
Or a very pleasant dream. Ikoala. Thank you, Ikoala. I appreciate the 30 months of support. Thank you for keeping me here online with that continual support. It means a lot to me. It really does. Thank you. Yeah, not too shabby, right? Look how big this is, too. Man. This is about as big as a Stegosaur skull would get, I think. Stegosaurus is one of the largest, if not the largest, of the Stegosaurs in the whole family. And he's got one of the biggest skulls. Probably the biggest. Looking good. Looking very good. Alright, let's see what else we can do. This part. Basioccipitals, I did that, and now didn't do that part yet. We're going in there. Let's take a look and see if it makes sense to do this part now. No, we don't, because we don't have that part on there yet. So our... Okay, we've got our post-orbital there. We're going to do our quadrate and our quadratojugal. And that'll attach to the jugal there also. So let me try and track these down. That should fit on there like that. I like that. That one might make more sense. Let's look at our instructions again. There we go. Yeah. Let's see. So that's gonna stick out there, and this goes right here, does it? Nope, hang on. Think about this. Okay. Again, trying to juggle a dozen different things at once right now. That attaches here. Okay. That makes sense. Nice. Okay. Excellent. So, next up, we've got this bone right here, the quadrate. So the quadrate is at the back of the skull, and it's got this prong that comes down like this and articulates with the lower jaw. So you've got the articular bone back here and the quadrate, and that forms the jaw joint right there. So this is going to be a really, really important part because this is kind of like a load-bearing part of the skull. This is what attaches to the lower jaw. So I got to make sure that this is a good connection right here. Let's do it. I'm just kind of do this really quick, putting the sport on. There we go. I'm just using super glue for this because I wanted to set up as quickly as possible. Sorry you can't see it right now, it's out of frame, but I risk lifting this up, jostling it, and then breaking that connection. Yeah. I want this to work the first time. So I'm just gonna hold it here for a second. We can visualize it. Yeah, thanks, Claire. Use your imagination. Here we go. Just holding this piece on right here. As steady as I can. That glue starts to set. There should be some other pieces that connect onto here that help stabilize it. We'll figure that out in a minute. And Claire says, such fragile looking teeth. Yeah, they're not... Stegosaurs were not eating super tough food. Whatever plants they were going after, it's not the toughest stuff around. And their teeth are fairly unspecialized looking. They're fairly basic looking for a plant-eating dinosaur. They're not using those teeth for chewing either. They're just using those teeth for kind of slicing plants so that there's chunks small enough to be able to swallow. That's what stegosaur teeth are for, basically. Does that make sense? Hang on a second. Do I have this backwards? That doesn't make sense. Does it? Nope. So let me show you what I'm a little bit confused about here. So I'm trying to get the... Right here. This bone right here connected on. But I'm not sure at what angle it's supposed to be. There's nothing that kind of indicates the exact angle. And again, this is what attaches to the lower jaw, so it should be really, really sturdy. This thing should be bulletproof. And it's not. So what I'm going to do is I'm actually going to set this aside for now. And we're going to work on another part. Once more of the skull is together, it'll become more obvious what's supposed to go on right there. Because yeah, at this moment, it's confusing. Anyhow. Let's see here. So yeah, the back of the skull over here should be pretty solid, and it's not at the moment. And I'm a little confused about what step I missed or how to kind of make that more solid. We can return to this step right here. I'll see if I can find this guy. There it is right there. And let's see if this makes sense. Like it could go on just like that, but that doesn't feel right. Doesn't feel right at all. Alright, let's move on to a different part and make progress somewhere else. Oh, it's supposed to go inside. That flange goes inward. I think this might be a good stopping point for today. I'm starting to get a little bit frustrated and confused about this. I'm trying to monitor chat, hold this at the same time, look at the screen, negotiate with all this stuff all over the place. You know, try not to run the skull into this every time I put it up onto the desk. I don't want to risk this thing falling apart and losing all the progress that we've made. So I'm going to call this for right now, and we're going to move on to something else here. Maybe I'll have an opportunity to finish this tonight. We'll see. Otherwise, we might be working on it tomorrow. I'll put that right there for now, and I'm going to kind of clean up my space. And we're going to get ready to talk about this brand new dinosaur. Well, brand new, and at the same time, very not brand new dinosaur. You'll see what I mean. So let's do that. Yeah. Why don't we play a quick welcome video for any new folks here while we do this, and that'll give me an opportunity to clean up, run to the bathroom real quick. Yeah, maybe eat a fistful of almonds. I'll be right back. So, without further ado, here comes our good friend, previously recorded Danny, sneaking up behind me. If you're new here, he's going to tell you a little bit about who I am, why a paleontologist is here on Twitch, all that good stuff. If you're not new here, well, then he'll tell you again, because I'm sure you've seen him before. Anyway, previously recorded Danny, take it away. Well, thanks, present day Danny. Well, if you happen to be new around here, then welcome to Paleontologizing. You may well be wondering to yourself, well, if this is Twitch, then where are the video games? I'm gonna level with you here. I don't really do much in the way of video games. I'm a paleontologist. My name is Danny Anduza, and dinosaurs are my area of study. But how in the world does a paleontologist end up on Twitch? Well, you're about to find out. When I finished high school, I moved to Montana and immediately started work at Museum of the Rockies, which at the time was an unparalleled powerhouse of paleobiology. That program was built by this guy.
Famed paleontologist Alan Grant.
Well, kind of.
You consulted on that movie.
I did consult on all those
and they
movies.
said the guy Alan Grant was you.
Yes, yeah, well, fortunately he didn't get eaten.
Meet Jack Horner, the real-life Alan Grant. He's one of the most prominent and controversial paleontologists in the country, a dyslexic MacArthur Foundation genius who never finished college and who says he doesn't care why dinosaurs went extinct. To him, the important part is how they lived.
It was at Museum of the Rockies, under the auspices of Jack Horner, that I learned how to be a dinosaur paleontologist. And a huge part of that I learned by working with Jack's final graduate student, a guy by the name of Denver Fowler, who would later go on to become curator of the Badlands Dinosaur Museum. Working with Denver, I did summer after summer of fieldwork in the remote Badlands of Montana. Together, we dug up more dinosaurs than we knew what to do with, at fossil sites numbering in the hundreds. In 2012, I discovered a new species of ceratopsian dinosaur, hopefully soon to be published. The next year, we excavated the world's smallest and youngest Tyrannosaurus rex. Then, we dug up a brand new ankylosaur.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
So we found its head, we found parts of its armor and plates, and so it should be a new species.
Not bad, right? Well, anyway, much like my fieldwork, my research also focuses on dinosaurs. For example, here's Trirarchuncus, the last of the Alvarezsaurs, just published in July of 2020. One of my current projects focuses on Spinosaurids. I can't really talk too much about that until it's a little bit closer to publication, so stay tuned for that. Anyway, let's get back to how I ended up on Twitch. A couple years ago, things in Montana were declining rapidly, so I picked up and moved on to greener pastures. I'm so glad I did. And with that new perspective, I also realized that I have very little patience with the soul-crushing bureaucracy within academia. So for the time being anyway, I decided to take my career in a slightly different direction. I got hired for a job in early childhood education. As a teacher, I get to have a positive impact on kids' lives and help them find a passion for science. Then, when COVID-19 showed up, the school had to close. But that didn't stop the teaching or the learning. We just moved online.
All right, friends. So we're going to be looking at a book in a little bit, but I thought we'd start off with a song. At 3, 2, 1. Oh, give me a home
where the hadrosaurs roamed, where triceratops bellowed and grazed, where erosion uncovers bones we seek to discover, for to strike the whole world amazed. Home on a range,
with a deer in the antelope play,
where seldom is heard a discouraging word, and the skies are not cloudy all day. It was a pretty easy jump from teaching online to streaming on Twitch. I had my first broadcast in May, and I've been on here ever since. Now, I believe pretty strongly that any good scientist should also be a public servant. In my opinion, talking to everyday people about her science is one of the most important things that a researcher can do. I now have a golden opportunity to reach out directly to people where they are. This is what I'm all about, and now, thanks to Twitch, I get to share it with you. And I'm so happy to be able to do so. It's my intention to continue this mission of education by answering your questions, providing good science content, and working to grow this channel. And if you could help by following, or if you could afford it by subscribing, I would be deeply grateful. So anyway, to my regular viewers, thank you again for sitting through this. To everybody who's new, welcome. I'm genuinely, earnestly glad that you're here. And I hope you stick around. We've got a remarkable little community here, and I'd be delighted if you join us. Anyway, let's go ahead and get back into it. So, present day Danny, back to you. Well, thank you, previously recorded Danny. And thank you for everybody for sitting through that again. I hope you're ready to talk about our brand new dinosaur here. Brand new. We'll talk about why that's so interesting. There's already been a few popular press articles about this, including this one at phys.org. Paleontologists discover a new species of North African predatory dinosaur in archived images. What does that mean? We're going to get into it. This piece of art is by Twitch's very own PaleoStream, Joshua Knupe. Can we get a shout out for PaleoStream here? Thank you, Claire. Excellent. So, PaleoStream, Joshua Knupe is an artist in Germany. He created this image. He's an accomplished paleo artist. Gorgeous work here. Just stupendous. If you think this dinosaur looks like Ceratosaurus, right here, don't be fooled because it's not related. There we go. SNSB and LMU paleontologists, not sure I know those abbreviations stand for, have identified a new species of predatory dinosaur from the Cretaceous period in North Africa, about 95 million years old. So again, to set the stage here, look at our time chart. 95 million years old would put it here in the Cenomanian stage, the beginning of the Upper Cretaceous period. Dinosaurs, except for a few birds, went extinct at the end of the Cretaceous 66 million years ago. We're up here in the Holocene epoch. It's so short it doesn't even show up on this. But we're up here in those black pixels at the very top. This dinosaur lived during the Cenomanian stage of the lower part of the Upper Cretaceous. Dinosaurs first evolved down here, probably the Ladinian stage of the Middle Triassic. So anyway, this dinosaur is from about the middle of the Cretaceous period. What makes this discovery so special is that the original fossil from Egypt was completely destroyed 80 years ago during World War II. It is a dramatic story. The researchers analyzed previously unknown archival photographs of the dinosaur skeleton from the period before 1944. The findings are published in the journal PLOS One, and we'll look at the actual paper here. The fossil's eventful history stretches far back into the past. The original skeleton of this large predatory dinosaur was described by the Munich paleontologist Ernst Stromer von Reichenbach. It was excavated in 1914 during an expedition in the Bahari Oasis in Egypt and was sent to Stromer in Munich shortly after. Though it was stored together with other Egyptian dinosaur fossils in the Bavarian State Collection for Paleontology and Geology, which at that time was located in the Old Academy in the center of Munich, Stromer assigned the fossils to the genus Carcharodontosaurus. Shark-toothed lizard is what it's called. It's named after the white shark, Carcharodon carcharocles. Carcharodontosaurus, the shark-toothed lizard. About 10 meters long, it was one of the largest land-based carnivores in the history of the Earth, comparable in size to the slightly younger, well, much younger, Tyrannosaurus rex from North America. Then the building was destroyed in a Royal Air Force bombing raid. To give you some background on this, to help you kind of understand what's going on. Yeah. Take a look at this. Here we go.
"100 million years before the birth of the first pharaoh, the deserts of Egypt were verdant Edens, teeming with life.
Yep.
At the top of this food chain, dinosaurs ruled.
Like Carcharodontosaurus here. This is at the center of our story.
Nearly 100 years ago, a German aristocrat named Ernst Stromer ventured deep into this wasteland, searching for clues to its prehistoric past.
Wasteland? This is a wonderland.
The strange monsters he discovered would astonish the scientific community, only to be blasted into dust by man-made fire from the skies.
Yep. April of 1944.
For the next half a century, a hidden world lay buried under these shifting sands, until a team of young scientists set out to resume Stromer's quest.
You'll recognize one of these guys.
Their mission?
It's Matt LaManna there. Yeah, we did fieldwork with Matt in Wyoming last year, back in June. It was a delight to have him on the stream.
To unearth the remains of the lost dinosaurs of Egypt. Their discovery? Something so unexpected.
Yeah, they found a sauropod. Anyway, let's get to this part here, talking about Stromer and Mark Graf.
Of Egyptian dinosaur in the early part of the...
There we go.
But I really didn't know anything about the guy who had discovered it until I was in graduate school.
German paleontologist Ernst Stromer discovered the massive carnivore Spinosaurus, along with 3 more species of Egyptian dinosaur in the early part of the 20th century.
Yep.
As with most of Stromer's finds from the African continent, all fossil evidence of Spinosaurus was destroyed in a World War II bombing.
I've known about Stromer's dinosaurs since I was probably 10, 11 years old. This man went to this exotic place, found a bunch of incredible dinosaurs, and they were all lost.
Yep.
It's almost mythical to somebody that was, so interested in the subject. Can I get a Boddington's, I guess? What do you want?
Anywho, let's go back to... They've got a few clips here where they talk about Stromer. They talk about these discoveries. Here we go.
The northern hemisphere. But most dinosaurs which lived on the southern continents, particularly Africa, remain scientific enigmas even today. But in 1910, one man would begin to explore that mysterious ancient world.
So he also found the fossils of this dinosaur that was just described. This new paper is about a dinosaur that Stromer found.
Born on December 5th, 1870, into an ancient baronial lineage, Ernst Stromer von Reichenbach spent a quiet childhood near his family seat in Nuremberg, Germany. Small of build and often in poor health, Stromer would ultimately find his calling in the evolving fields of geology and paleontology. In the early 1900s, Stromer learned of some fossilized prehistoric mammal bones recently uncovered in Egypt.
And so the thing about Stromer is that he was a consummate scientist. Ernst Stromer wanted to find out what was true, regardless of how anybody felt about it, regardless of, you know, the political winds of the day, any of that stuff. He wanted to know what was what, no matter where it led him. In Germany at the time, there was this idea that, like the evolution of humans and other mammals, it was probably outside of, it may have been in Europe, it may have been in Asia, but the idea that human beings first evolved in Africa, Germans by and large hated this idea for largely racist reasons. They didn't want Africa to be the cradle of humanity. Stromer suspected that it was. He thought that the African continent was really, really important to the evolution of what he called the higher mammals, things like humans, primates, stuff like that. And so regardless of what other people thought, regardless of the political inclinations of the day, he's like, I'm going to get down there to Africa, and I'm going to look for fossils. I think that humanity may have come out of Africa. That's why he went to Egypt.
At the end of 1910, he mounted his own expedition to see what other fossils Egypt might possess.
Es war so, es gab ja damals noch nicht die moderne.
It was a strenuous journey. There were no cars. He had to rely on local means of transportation like camels. He had no plan for provisions.
He's kind of winging
Stromer
it
and
in a
his team
sense.
trekked nearly 200 miles across the desert. It would be 8 days before they reached the then primitive outpost of the Bahariya Oasis.
January 13th, 1911. I arrive in Bawiti and meet with a local official. The official tells me that I probably won't find much.
After exploring some disappointing sights, Stromer came upon Jebel el Dist.
There's a photo
There
of
he
it from
found his
1911.
first significant fossils. Tantalizing glimpses from the Earth's primeval past.
Some vertebrae of dinosaurs, a
January
rib.
28th, 1911. In cold weather, I search through the hills. I find among these layers 3 large bones. Apparently, these are the first dinosaur bones that have been found in Egypt.
Stromer found a diverse dinosaur fauna with 2 standout key players, one by the name of Spinosaurus and the other Carcharodontosaurus. We're talking about
Yeah, and this animal gets a new name. That's what this paper is about. That's what this is so exciting.
dinosaurs approaching the size of Tyrannosaurus rex, which was long believed to be the greatest meat-eating dinosaur of all time. No longer is. Move over. You got competition.
While Stromer immersed himself in the extinct species of the Cretaceous, his own 20th century species was focused on its most destructive pursuit.
Yeah.
Making war on itself.
In August 1914, World War I broke out, and the material collected by him was still in Egypt. 12 big wooden crates taken by the Anglo-Egyptian officials were not allowed to leave the country.
So already a big delay in Stromer's science because of World War I.
Ernst Stromer's hard-earned fossil finds had become hostages of war. Nearly a century after Stromer's setback, Josh Smith.
Anywho, let's continue and get back to our story here. They kind of interspersed this with stuff around 2000. Let's see here. Don't want to miss any of this. I'm just scrubbing through, looking for historical footage and photos. And when to stop.
Yeah, this is an old quarry.
So they've
I don't even know what to say.
they've relocated one of Stromer's
The
quarries
expedition team makes their
from
first
1911.
direct link to Ernst Stromer.
It might be in part 2, Claire, yeah.
Nearly 100 years before Josh and his colleagues first set foot in Bahia, German paleontologist Ernst Stromer excavated tons of fossils from the same lonely patch of desert. The tragedy of Stromer's lost dinosaurs began in 1914, when Egyptian and British officials
And Claire Burr, this spans World War I and World War II. So yeah, it is the same story with Spinosaurus and the RAF. Yeah.
confiscated his final
Yeah.
shipment of fossils at the port of Alexandria.
Yeah.
The specimens did not reach Germany until 1922.
That's crazy, you know? We talk about sometimes it'll be decades after a fossil specimen is found that it actually gets studied or published on. Stromer didn't even have the fossils in his hands again until 1922. It was like 11 years later, you know?
When it finally got to Germany, apparently it was in fairly sad shape. Apparently it had been unpacked and repacked, and that's of course always a prescription for disaster, particularly at a time when people were not very good yet about preserving fossils.
Yeah.
With the materials finally back in Germany, Ernst Stromer spent several more years trying to overcome these setbacks.
Being a paleontologist is not just making the finds, it's also writing about them. I don't know that he was particularly unhappy to come back, although he had very happy memories of being in the Middle East, I know that. Not the least because he met his wife there, of course.
Stromer was still working in Egypt when he first met Elizabeth Rennebaum, the daughter of a British architect. Years later, a chance encounter in Germany led to their marriage in 1920. During the following years, the couple raised their sons Ullmann, Gerhard, and Wolfgang at Stromer's family seat, the 9th
Don't get too attached to those kids. Oh boy. Yeah.
century castle Stromer von Reichenbach, their private haven in a quiet forest just outside of Nuremberg.
My husband, although not completely uncritical of him, really worshipped him. Yes, he must have been a very good father, very strict.
Stromer continued to press forward with his work, authoring painstakingly researched monographs describing a complex equatorial ecosystem. Stromer discovered several distinct species of T-Rex-sized predators, including Carcharodontosaurus, a carnivore with a 6-foot-long skull.
So he didn't call it Carcharodontosaurus at the time. He called it Megalosaurus saharicus, if I remember correctly. But again, this is central to our story, so eyes on the prize here. Remember, Carcharodontosaurus. Yeah.
Carcharodontosaurus. The name means shark-toothed lizard. And this is a dinosaur that was sort of the equivalent of a shark on land. It would have basically walked up to a sauropod dinosaur and probably taken a big chunk out of it and just sort of waited for it to die.
Maybe. We don't really know exactly how they hunted, but it's an interesting hypothesis. They didn't have the kind of bone-crushing teeth that T-Rex had,
Carcharodontosaurus
like we were talking about yesterday.
survive in a desert.
Yeah, well, it wasn't a desert back then. Yeah. Here, let's find part 2. There we go. And let's scrub through until we get back to the story with Stromer. I didn't realize that we were, shoot, it's it's after 6 o'clock already. I've been already streaming for 5 hours. Putting together at Stegosaurus took way longer than I thought it would. So, yeah, we're just kind of cruising through this.
In 1941, Ernst Stromer was among the millions swept up in a storm of another kind.
Oh boy.
The Second World War. Stromer himself openly opposed the Nazis' cause.
And the only reason that he could do this without being killed by the Nazis is that he happened to be a German aristocrat. You know, he was like a member of the upper echelon of society. And so it's, I don't know. That's the thing about Nazis and other fascists, is that they're all about like hierarchy. So if you're in like a high social standing, sometimes they'll leave you alone, like they did to Stromer. Kind of. They did try to make his life miserable in a lot of ways, and they succeeded. That's how the dinosaur fossils ended up being destroyed. It was ultimately the fault of the Nazis. They don't really talk about that in this documentary, but I'll tell you about it. But anyway, know that Stromer was opposed to the Nazis. You know, he's a scientist. He had lots of colleagues who were oppressed by the Nazis. He had, you know, Jewish colleagues that he really got along with well. He worked with, you know, he was appalled at their treatment by the Nazis, and he spoke out against that, and they tried to make him suffer for it.
He was very bitter against the National Socialists for the character of the war. He didn't accept this war at all.
Traditionally, Baron Stromer von Reichenbach's standing as a member of the German aristocracy would automatically qualify his three sons for officer status.
Yep. So they should be on Easy Street. They shouldn't be digging latrines or fighting on the front lines. They're like high-born members of society. They're the upper crust. You know, their dad's an aristocrat. But he was an aristocrat who opposed the Nazis. Nazis didn't like that, so they sent his sons to the front lines.
But Stromer's vocal opposition to the Nazis meant his sons Ullmann, Gerhard, and Wolfgang would become virtual cannon fodder, sent to the front lines as infantrymen.
At the beginning of the war, my husband and his elder brother were naturally drafted immediately. His elder brother died in Russia, which was, of course, an enormous blow for the family. I also know that Ernst didn't show very much emotion about it, but felt it all the more.
In 1945, 17-year-old Gerhard Stromer was killed in action a few months after his enlistment. Less than 2 weeks later, Germany surrendered.
Jeez.
Ernst suffered naturally appallingly under the death of the two boys, and just went downhill after that.
2 weeks before the war ended.
Russian soldiers captured Stromer's only surviving son, Wolfgang, incarcerating him in a prison work camp.
There was a particularly long time where they didn't know what had happened to him.
They thought he had died.
World War I had forced Stromer to abandon many of his important Egyptian discoveries on a pier in Alexandria. The Second Great War committed 2 of his sons to the ground, another to a Russian labor camp. But Stromer would sustain one more grave loss.
Brings us to our paper today.
April 1944.
So here's the thing. At this time, Germany is being bombed by the Russians, by the Americans, by the British. And so a lot of, well, we're talking about museums. Germany was full of museums at the time. Berlin and Munich and, in Vienna and Austria. Typically, really important items in these museums would be taken out of these city centers, brought up into the mountains, into salt mines, and places like that where they're going to be out of harm's way. Many of the important specimens in the Munich Museum had already been squirreled away to safety. The Nazis wouldn't let Stromer do this with his dinosaurs. They hated him so much that they said, no, these have got to stay here. If they get destroyed, they get destroyed. And guess what happened?
In a determined effort to wipe out Munich's communication and railway systems, Allied bombers reduced whole blocks of this Bavarian city to ashes. When the smoke cleared, the Munich Museum of Paleontology, located near Nazi Party headquarters, had also been devastated. Virtually all of Ernst Stromer's fossil finds from Egypt were destroyed. Despondent over this series of losses, Stromer and his wife clung to the hope that their last surviving son would come back to them alive. The Russians finally released Wolfgang Stromer in 1950.
My grandfather was very, very happy that at least one of his sons came back. He just survived to see my father back and see him married and know that I was to come.
Ernst Stromer passed away at the age of 82 on December 18, 1952. During the years following his death, Ernst Stromer's scientific legacy slowly began to fade, becoming an historical footnote to all but the most dedicated paleontologists.
So those fossils that had been destroyed in the museum were unique. There was nothing else like them in the world. Spinosaurus, Bahariosaurus, Carcharodontosaurus, Egyptosaurus. You know, lost to science. The holotype specimens destroyed. But this crew, Matt LaManna and co., made some... They found out some interesting things when they visited Munich.
While Jason begins his exacting work, Josh, Matt, and Ken set out to discover more about the man who inspired their mission. The journey takes them to Munich's Museum of Paleontology.
God, they were ugly spuds, weren't they? We had a twofold mission in coming to Munich. Partially, we wanted to learn more about, well, who is this guy Stromer? What makes him tick?
Curator Dr. Helmut Mayer and the scientist are the first people to dig through a collection of personal papers, donated to the museum by Stromer's son, Wolfgang, just before he died.
Stromer with the Bahariosaurus femur.
So there's that famous photo right there. This might be an original of Stromer and I think the Bahariosaurus femur.
That's cool.
The items include more than 100 never-before-seen glass slides, taken by Stromer and his colleagues during their expeditions to Egypt.
Oh, look at this.
Oh, beauty.
Libby
great find, baby. Oh, man, please have some of your dinosaurs. Please have some of your
Look at that.
Yeah, please have.
Holy cow.
Figure, but I wish.
That's a photo, dude. This is a photograph.
Oh, man.
Excuse me.
Nobody knows these exist. Nobody knows these exist. It's really awesome.
God.
I know, I see. Oh, man.
He had it mounted.
There's your
He did?
He had it mounted.
Yeah.
I realized, ooh, this is Spinosaurus in the museum before it was bombed.
Yep.
All of a sudden, we've got a photograph.
It was on display in the museum.
Rather than just Stromer's drawings. So we can get information from the original Spinosaurus that no one has access to.
Back in a Philadelphia bar the year before their expedition, Josh and Matt dreamed of finding an associated skeleton of a Spinosaurus.
Look at this, Matt. He had it freaking mounted.
Now they've discovered the only one in the world. Not in a bed of rock, but in a box of memories.
This piece of...
And so this is kind of the perfect jumping off point to our new paper here. Because these fossils have been destroyed. They were completely annihilated in that bombing raid in April 1944. But here, with our new dinosaur, the researchers analyzed previously unknown archival photographs of the dinosaur skeleton from the period before 1944. These findings are published in the journal PLOS One.
The infant?
Original Old Dog, thank you.
The adult.
For the 23 months of support.
Ontogeny.
I appreciate that.
Can they 3D print from those photos?
They can't 3D print from the photos directly, but you could potentially try and digitally sculpt things based on those photos, or you could just work from the photos and publish based on that, which is exactly what they did here. The only remnants of the Cretaceous dinosaurs of Egypt are Stromer's notes, illustrations of the bones, and a few photos of the original skeletons, including this one right here. During new research, the paleontologist Maximilian Kellerman, a master's student at LMU München, came across new, previously unknown photos of the predatory dinosaur, what we call Carcharodontosaurus. We called Carcharodontosaurus until this publication. The pictures show the original skeleton from Egypt, parts of the skull, spine, and hind limbs, before its destruction in the exhibition at the Alte Academy. Kellerman evaluated the new images together with dinosaur specialist Professor Oliver Rauhut from the Bavarian State Collection for Paleontology and Geology, and Dr. Elena Cuesta from LMU. What we saw in the historical images surprised us all. The Egyptian dinosaur fossil depicted there differs significantly from more recent Carcharodontosaurus finds in Morocco. Stromer's original classification was thus incorrect. We identified a completely different, previously unknown predatory dinosaur species here and named it Tameryraptor markgraffi, said Maximilian Kellerman, first author on the study. Tameryraptor was about 10 meters long. It's about the size of a bus. Had symmetrical teeth and a prominent nasal horn. The name refers to the ancient name for Egypt, Temery, the Promised Land, and honors Stromer's fossil collector Richard Markgraf, who excavated the dinosaur's remains. The researchers found that the dinosaur was closely related to the North African and South American Carcharodontosaurs, as well as to a group of predatory dinosaurs from Asia, the Matriacanthosaurs. Interesting. It's close to Matriacanthosaurs too? Presumably the dinosaur fauna of North Africa was much more diverse than we previously thought. This work shows that it can be worthwhile for paleontologists to dig not only in the ground, but also in old archives, said Rauhut. However, a more comprehensive assessment of the Cretaceous predatory dinosaur fauna from the Bahari Oasis would require the recovery of more fossils from the site. So it's photos like this. Lovely. We've got a femur right here. We've got a tibia right there. We've got a vertebra. This looks like maybe a caudal vert right here. The tail. And we've got a nasal. We've got a maxilla. We've got some of the bones, presumably from toward the back of the skull. But look at that projection right there. Look at that bump right there. That is the basis for the horn, like you see right here in Yoshua's illustration. Yeah. Very cool. Here, let's look at that paper. And this is open access. Here is a link for you right there.
Access granted.
So PLOS One, Public Library of Science. This is an open access journal. Publish some good stuff. Here's the actual paper. So let's read the abstract, a short summary of the paper at the beginning. The first partial skeleton of a Carcharodontosaurid theropod. So Carcharodontosaurs are these guys, the shark-toothed lizards. Giganotosaurus, Mapusaurus, Tyrannotitan, Carcharodontosaurus. Probably seen this famous image before of Carcharodontosaurus and Deltadromeus. Yeah. Cool critters, these guys. Their skulls are about the same exact length as T-Rex's skull. Not as heavily built, not as robust, much narrower from side to side, but similar length, similar height, you know? These guys probably got a slightly bigger than T-Rex, although we don't have complete skulls from any member of this family, so knowing the exact dimensions of the skull is, we don't have those exact dimensions. So the first partial skeleton of a Carcharodontosaurid theropod was described from the Egyptian Bahari Oasis by Ernst Stromer in 1931. I bet you we can find that original paper, too. Stromer's original 31 paper. I bet you I've got it in my PDF library here. Here we go. Stromer, 1931. Let's find it. There we go. So here's an English translation. And I don't know if this one has figures, but the other one might. I don't see figures here. Let's try this one. This might just be text as well. Yeah. But anyway, that's the original paper in German. Stromer referred the specimen to the species Megalosaurus saharicus, originally described on the basis of isolated teeth from slightly older rocks in Algeria. Not even in Egypt, in Algeria. Under the new genus name Carcharodontosaurus saharicus. Unfortunately, almost all of the material from the Bahari Oasis, including the specimen of Carcharodontosaurus, was destroyed during World War II. In 1996, a relatively complete Carcharodontosaurid cranium was described from similar-aged rocks in Morocco, and designated the neotype of the species Carcharodontosaurus saharicus in 2007. So this was, Paul Serino found this. Well, Paul Serino's associated with, I don't know if he actually found it, but he was expedition lead at the time, as I understand it. I think we've got oops of that here. Nope. That was a different one. I don't know if I'm going to find that in time, but that's okay. Here, I can find you that famous photo of Reno and the Carcharodontosaurus skull, though. I think this is a Luis C. Hoyos photo for National Geographic. This is a big deal in the 90s, you know? Big deal. So, however, due to the destruction of the original material, comparisons of the neotype to the Egyptian fossils has so far only been done cursorily. So nobody really sat down to compare the stuff from Morocco to the stuff from Egypt in great detail, you know? Especially not using archival photos that nobody knew about until now. A detailed re-examination of the available information on the Egyptian Carcharodontosaurid, including a previously undescribed photograph of the exhibited specimen, reveals that it differs from the Moroccan neotype in numerous characters, such as the development of the emargination of the antorbital fossa on the nasals, the presence of a horn-like rugosity on the nasal, the lack of a dorsoventral expansion of the lacrimal contact of the frontals. These are all skull bones that we were looking at earlier in the stream. And the relative enlargement of the cerebrum. This referability of the Egyptian specimen to the Algerian M. saharicus is found to be questionable, and the neotype designation of the Moroccan material for C. saharicus is accepted here under consideration of ICZN Article 75, as it both compares more favorably to M. saharicus and originates from a locality closer to the type locality. Okay. A new genus and species, Tameryraptor markgraffi, is proposed for the Egyptian taxon. The theropods of the Bahariya Oasis and the Moroccan Kemkem group are thus not as closely related as previously thought. I've been saying this for years. This is great. And the proposed faunal similarities between these two strata need further examination. Yes. Yes. Very cool. So yeah. Basically, this material right here, these leg bones, this vertebra, these skull bones right here, look at that little hornlet thing on top of the nasal. These are different enough from the Moroccan Carcharodontosaurus. These authors say it deserves a new name. This is a different kind of dinosaur entirely. And thus they name it something new. And apparently they can do that based on a photograph? Is that the idea? So the holotype of Tameryraptor Mark Graphi. Photograph of the mounted specimen at a point prior to April 1944. Yep. And the left maxilla of Tameryraptor, photographed in medial view. Okay, this is also before April 1944. See one of the teeth right there. Interesting. Very, very interesting. So, here we go. We're going to get into the weeds just a little bit about this. We're going to talk a little bit about the ICZN. So the ICZN is the International Commission on Zoological Nomenclature. This is a group of scientists with a rule book. They kind of dictate what are the rules for naming animals. It's important to have a set of rules for something like this in order to eliminate confusion, keep the same animal from being named twice. You know, they kind of tell you what you can and can't use to name a new critter, all of that stuff. It's important to have a set of rules so that everybody's on the same page, you know? Here's a link if you want to read a little bit more about that right here. So the actual code is in a book, and I've got an older edition of it right over here. There it is. The International Code of Zoological Nomenclature. And it does not make for very thrilling reading. So we're going to read the whole thing. No, I'm kidding. I just want to page through it and show you. We've got it in French. We've got it in English. Name is based on personal names. So, basically, every situation they could think of here, they outline. Here's what you can and can't do. Types of words eligible as genus group names. Stuff like that. Derivative Greek nouns formed by the stems by the addition of suffixes that change their meaning. Such words may have been used in Greek or may be coined for zoological use. For instance, stomach, blah, 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 blah. Anyway, if you want to name a new critter, it's got to conform to these rules. If you want to name a new animal, you want to make sure that you're playing by the rules here. And so they talk at length about this in the paper. Nomenclatural acts. This is, you know, naming this thing. Here's what they were getting up to. They're going to justify their decisions here. The electronic edition of this article conforms to the requirements of the amended International Code of Zoological Nomenclature, and hence the new names contained herein are available under that code from the electronic edition of this article. They put it in ZooBank. All this stuff. Yeah. So, oh, lovely. Here is a skeletal of this animal. And look right there at that nose horn that they're interpreting from that bump on the nasal right there. Really interesting stuff. Yeah. Very cool. They're kind of implying there's a keratin sheath over the top of it that would have embiggened that horn significantly. Which I buy, you know? So... Here's the photograph. I want to see where they justify using a photograph as the holotype. Yeah. Let's see. Although all of this material has been destroyed, here we attempt to provide a description as detailed as possible based on Stromer's descriptions and illustrations, as well as the photographs of the material. Measurements of the specimen are given in the supplemental material. Noteworthy feature of the nasals is a 3 centimeter high nasal horn, which is clearly observable in the photograph of the exhibited specimen. Here we go. There we go. Specific reasons for designation of an unpreserved specimen as a name-bearing type. So this is from section 73G of the code. This is the rule in this book that says, well, shoot, if the original specimen has been destroyed, I guess you can use a photo. Yeah, the specimen was undoubtedly destroyed in World War II, and no comparable extant specimen is present. Consequently, direct observations are not possible, and a revision, as undertaken here, can thus only rely on the published descriptions of the illustrations and the newly recovered photographs of the specimen. And Fedorasaur, thank you for the raid. How are you doing? How was your stream? Welcome back. We're, Stego Stampede. Hello, let me see them kitties. Hello, hello. We're going over this new paper describing Tameryraptor, which is a new name for Stromer's Carcharodontosaur from the Bahari Oasis in Egypt. Let me see them kitties. Thank you for the follow. Welcome, welcome.
But on the land, the greatest of all the reptiles,
thank you,
the
Fedorasaur,
dinosaur, was king.
Thank you very much for the 40 months of support. Holy cow, Fedorasaur. I appreciate you. And Axeman says, I wonder if this will start a trend of publishing on photographs of privately owned specimens. You couldn't do that because the specimen exists. You can only do this if it was a specimen that was previously published, and then it was destroyed, but photographs still exist of it. You can't do that for a privately owned specimen, because it still exists, you know? This is an animal that was published in the past under a different name, and here... yeah. Anyhow. This critter was previously published. It was in a museum. The museum was destroyed. Photographs and publications of it exist. And so here they're saying those photographs and that original description by Stromer, we're going to give it a different name now. Does that make sense? Yeah. And it could become problematic quickly otherwise. Yeah, that's why we have a code, you know? So that you can't do stuff like that. You can't get too crazy with it, you know? Anywho, good stuff. So, Tameryraptor means thief from the beloved land. It's a combination of one of the more informal ancient Egyptian names for Egypt, Ta-Meri, meaning beloved land, and the Latin word for thief, raptor. And Markgraf I is in reference to Richard Markgraf, the Austrian fossil collector who discovered most of the dinosaur remains described by Stromer. Richard Markgraf.
I can see that my
Axeman,
has been well spent.
thank you for the 17 months at tier 3 now. Really appreciate that. Thank you, Axeman. Appreciate you. There's Markgraf right there. I've got his photo up on the wall. It's not a very big photo. It's not very high res. Here it is right here. I've also got Ceratosaurus on display today. It's got a nasal horn, not related to our dinosaur today. not related to this critter, who's a Carcharodontosaur. Anywho, yeah. Anyway, yeah. Yeah, good stuff. Back to our paper here. There we go. So the holotype, this specimen now destroyed. The specimen includes part of the left and right maxilla, both nasals, parts of the brain case and endocast of the brain case, 3 cervical vertebrae, In the absence of the actual specimen, the descriptions and figures of Stromer and the photograph at UAT stand as representatives for the holotype in accordance with ICZN Article 73.1.4. So yeah. Good stuff. So if we want to designate, like if we want to be able to tell this dinosaur apart from all other dinosaurs, here's how to diagnose it. It's got a few different autapomorphies. Those are totally unique characteristics where no other dinosaur has this. A small nasal horn on the medial rim of the nasals. Prefrontal facet on the frontal, not expanded. Frontals vaulted dorsally. Interesting. Internasal suture inclined ventromedially. And anterior middle caudal vertebra with well-developed pneumaticity, including foramina posterior to pre-zygapophyses opening into spino-pre-zygapophyseal fossa. And then a few other things, too, that are distinct but not necessarily autapomorphies. So, do we have a phylogeny in here? Let's see if they've got a family tree in there for us. If they don't, that's fine. There's that lovely reconstruction by Joshua Knupe, by PaleoStream himself. Very, very cool. And no cladogram. Well, it's actually kind of refreshing. What do you need a cladogram for? Cool stuff. Again, if you want to read this paper yourself, here is the link. It is free to download. No paywall. Good stuff. So now this marks 3 new dinosaurs. Well, some of these were kind of published last year, but anyway, TAMERYRAPTOR is definitely new this year. Archaeocursor is new this year, and Iavetum is new this year. So we've got at least 3 new dinosaurs so far in the year 2025. That's more than 1 per week so far. We're off to a good start. This is something that I was presenting on at the Society of Vertebrate Paleontology meeting. Here we go. Back in at the end of October, looking at the number of new dinosaurs published each year over the past decade. 2024, we're finally starting to come out of that pandemic slump right there, and it looks like 2025 thus far is off to a good start. Here's hoping that 2025 sees 50 or more new dinosaur species in the general published. We're off to a good start. Anywho, it is... I've been streaming for almost 6 hours at this point, so we're going to wrap things up here. There we go. Here's a Smilodon to throw our credits over. And let's find somebody to raid here. Don't go away just yet. We're going to see if we can continue the science. Who else is on? Rhacodactylus is on. Well, we're going to be having a special guest appearance from Rhacodactylus on tomorrow's stream. So, he's the perfect raid target for today. Pretty, thank you. Your name is showing up here in the credits. Extra big thanks to you. New followers, subscribers, resubscribers, cheerers, gifters, raiders. Buddy Hot. Thank you for the follow. Welcome, welcome. Hope to see you tomorrow. Thank you, moderators, for all of your hard work. I appreciate you. Thank you very, very much for everything that you do. Good stuff. Good stuff. Extra long stream today. Let's go see what Rhacodactylus is up to. And we'll have him as a special guest on tomorrow's stream. Join us for that. All right, take care, everybody. I'll see you tomorrow.